some quick housekeeping items and some logistic updates. So maybe joining me here. First of all, I'm Calvin Cam, and joining me here is Janice.
Thank you for being here. I think I spoke to probably all of you online. So just a couple of things: housekeeping, ground rules. Trying to get my.
You can get this too.
Oh, I see.
Sorry.
Okay, so just press this one.
Yeah.
Okay. So Stanford Wi-Fi. There's a Stanford Visitor Wi-Fi. You should be able to see it. It's called Stanford Visitor, and basically you just need to click on it, and then it'll open up a browser, and then you can connect to it. You just have to acknowledge, and then it'll connect you. So we have people joining us in the room. We also have people joining us virtually on Zoom, and everyone will have a chance to speak. Even the people virtually will be unmuting them. So please raise your hand, your physical hand and your virtual hand. For Zoom people, I think you guys can see the little hand. You probably can see me right now. Oh yeah, you are seeing me. But yeah, please raise your hand, and then we're going to take turns. We're going to have someone in the room speak and someone on Zoom speak, just so that we hear from everybody. And lunch options. So not for the virtual people, but people in the room. I think most of you will be joining us for lunch buffet. Otherwise, there's a Coupa Cafe downstairs. So those are the lunch options at the moment. So just some metrics. We have 24 people registered to be here at Stanford, a total of about 250 registered in total from 15 different countries, which is very, very nice to see, representing 30 plus asset owners. So from state DOTs to Facebook, Apple, Genentech. So we have quite a few representations today. So those of you here, you probably have it in your hand, the agenda. This is the agenda for today. We're starting off with global presentations from different cases. And then in all cases, we will have a Q&A session. We will also have a scoping discussion, and we want to hear from you. So speak up. And then in the afternoon, we'll be focusing on US cases, US examples, and also be having a discussion as well. So when I say scoping, that would be like the discussion, right? We will be using planmedone.com to document our discussions today and some takeaways, as well as next steps and actions. So we will be sharing the meeting report with you after today. Now, just want to say special thanks to our co-hosts. PBL, Renata is online, Building Smart USA, Ian Howell, Saifi, Kelvin, many of us are, for Saifi. Our sponsors, PBL, SBI, planmedone.com, and ACCA. And now I'm going to hand it over to Renata to say hello to us.
Hello, everyone, and I would like to say good morning, good afternoon, and good evening. And for all our colleagues that are there in person, we want to actually demonstrate a hybrid Renate. So for now, I'm joining you on Zoom, and in the afternoon, I will meet you in person. And for all the cyber people, we hope to see you eventually at Stanford. Please come visit. We love to share lots of ideas and especially introduce you to our wonderful community and students. So just to reiterate, my name is Renate Fruchter, and I'm the founding director of the PBL lab in the Civil and Environmental Engineering department at Stanford University. And I am also a long-standing member of the Saifi group here in our department, almost from its inception. I want to just say thank you to Calvin, my wonderful colleagues at SBI, who worked jointly with us to have this really inspirational workshop that I hope will be a launch pad for many more discussions. So as you will see, as seeing is believing, these are very exciting times for our industry as well as academic world. When the physical and digital worlds start to merge, and where everyone and everything that is connected to the internet becomes a data source, where IoT and AI and machine learning, VR, XR, robotics, autonomous mobility will continue to reshape how and where we live and work. So how will they augment and transform our building industry is a key question that we ask every day together with our researchers in the PBL lab. And just a couple of words, our mission at the PBL lab is to prepare the next generation of AEC leaders, innovators, and change agents. And those that are at Stanford in person and plan to join us tomorrow, you'll hear more in the afternoon about our program, where you will see what our brilliant students are working on. So it is really a wonderful, growing and vibrant global learning network that we have created over the last decades. And for us, the PBL lab is our sandbox where we reimagine collaboration, experiment with emerging technologies, and formalize their impact on individuals and teams and their team dynamics on product and process, as well as look at how they impact occupant well-being and harmonize that with sustainable built environments. So the PBL lab is the home of the AEC Global Teamwork class. I've been teaching since 1993 with university and industry partners worldwide. And here you see kind of our growing list of university partners, more than 30 universities on every continent, as we love to bring students together from 5 disciplines: architecture, structural and mechanical engineering, construction management, and lifecycle financial management, as we look at public-private partnership frameworks, as the students learn to collaborate in globally distributed project teams to virtually design and build university buildings that address local hazards such as earthquakes, hurricanes, and flooding. And I know we are on a tight schedule, and I will tell you a little bit more about tomorrow's schedule this afternoon. And again, thank you, Calvin and the SPI team for joining forces and bringing together additional interested leaders in our AEC community as we look both at the vertical and horizontal built environment and push together the envelope to really understand how digitalization, industrialization, and our response as an industry to the climate change big challenges is really implemented. So wonderful lineup of talks, and thank you for sharing your projects and inspiring all of us. Back to you, Calvin.
Thank you, Renata. Maybe at least for those of us in person, we'll give a round of applause for Renata, and we look forward to seeing you in this room in the afternoon. Renata has been basically one of the founding members of our Building Smart USA Education Committee. Renata, along with many committee members, have been really giving a lot of good guidance from our professional certification to how we should be engaging the young generation. Why we are having this workshop today, right here, It's exactly because tomorrow it's going to be the 30th anniversary of Wanata's Global Teamwork class. And we hope that many of you in person can join us tomorrow to experience how Wanata has been doing that for 30 years and counting, and how we bring the future of workforce in terms of global teamwork, in terms of leveraging technologies, leveraging digital workflow. And that also is the reason why we want to also rethink about how many of us as working professionals should also be rethinking about the future of how we engage client requirements, asset, facilities management. So thank you, Wanata, for not only inviting us to your 30th anniversary, witnessing your students' work, but also co-hosting and organizing, co-sponsoring this event today. So thank you, Wanata. All right, another co-host today we have, it's Building Smart USA. So joining us here, it's Ian Howell, who is our leader of Building Smart USA and Building Smart International. So Ian.
So perhaps if you
if you don't mind to come so that our remote participants can come see you. So right, because the camera's right here. Yeah.
Certainly, yes. So I'm actually the US representative for Building Smart International. Building Smart International is an open standards organization. It's not for profit, it's vendor neutral, and it really looks to the building and industry domain to try and facilitate interoperability through open standards. And we have published what's called an IFC schema, which is now submitted for ISO. We are doing that on a consensus basis. We have more than 30 chapters worldwide. So the US chapter is one of about 30 different chapters, collaborating with domain experts around the world to create a data schema that can in fact be used to try and make efficient digital workflows. Our US chapter kind of mirrors the international organization in that we're organized by domains. So to Calvin's point, we do have an education and certification committee. We do run training and global certification in the use of open standards. And certainly these industry committees are industry leaders from US industry around the topic areas of roads and bridges. We have a building room, which is a partnership with the BIM Forum. Some of you may know the BIM Forum from years of old. That's a great partnership in terms of how open standards can be promoted to hands-on BIM users. And then we are in the stages of formulating a rail industry committee, because there's been a lot of work done with infrastructure extensions to the open standard that include rail organizations from Europe, but not yet being used by US industry. The good news on the roads and bridges side is that we have an AASHTO resolution as a mandate for the open standard to be used for engineering data as all the state DOTs transition from CAD to modeling, bridge modeling and road modeling, and trying to make sure that data can be used for ongoing asset management, and hopefully, albeit with challenges in early stages of implementation, which we'll hear about from Caltrans, really allows that rich data to be used for decision-making, for project delivery, design, construction, and of course, ongoing asset operations and maintenance. So that's our role today, and we're very happy to co-host. Thank you, Calvin.
Thank you. Thank you, Ian. All right, a third co-host we have today, it's Saifi, Stanford University Center for Integrated Facility Engineering. So today we have three Saifi PhD students who will be presenting to us to learn about what may be the research and what may be some global practice. At the same time, as Wanata also briefly introduced, Wanata has been an important member of Saifi since its early days to can track some of the earlier roadmap. So Saifi was founded back in 1988, and decades in counting, we are still in the intersection of where industry advances with industry members come together with researchers. Not only do we have civil environmental engineering research students here at Stanford, we also work a lot with other departments from computer science, business school, and beyond. And that's also where lots of the professional education have been originated. By now, there are hundreds, if not thousands, probably thousands of professionals who have taken the 3DC course from SciFi, and recently in collaboration with Stanford Center for Professional Development. So we are very thankful for SciFi to be co-hosting this event today, and also would encourage many of you to stay tuned and join us for many more SciFi events to come. So with that, why we call this a workshop? Why we are having kind of like a small room discussion connected with our global Zoom presence is that we want to focus on how we can leverage technology and digital workflow and what we can do with these technologies in a shorter term of time. So where we are today is that we will run through a number of short presentations. We asked many of the presenters to try to keep their pitches into almost like an elevator pitch, keep it to be around 12 minutes or so that we focus more on demonstration of what has been done, of proven examples, but so that together in person and those of us joining us remotely can think about what we can form together. We want to see, say, by the end of the year, can we formulate a pilot or a set of pilots based on proven global examples? We'll see many of them this morning, but we are not seeing them enough or in an integrated manner enough here in the US or globally. So that's what we're trying to achieve today, and we'll get more to it later on. So our first lineup, and because of the time zone, we have East Coast guests joining us pretty late in the morning, but we also have a number of Europeans joining us pretty late in the day. So which is why that we'll start globally with presenters from the Netherlands, from Norway, from Finland, and then we'll slowly come back to California. All right, so our first presenter will be Rick Klooster and the team joining us from the Netherlands. They will tell us more about what they have been doing with Estonia, with Digital Netherlands, both covering infrastructure projects as well as smart building projects, and what we can learn from their use of open standards. So let's turn it over to Rick.
Yes, thank you. Do you hear me?
Yes, we can hear you well from Stanford.
And you also see my screen?
And yes, we can also see a screen.
Great, then all the technical stuff is working. Yeah, first I want to thank you for this opportunity to join this meeting. It sounds like a really great plan, especially the seeing is believing. I'm Rick Klooster from Future Insight from the Netherlands. I'm here together with my colleague, Dennis Borst, who's also turned his camera on. We're a Dutch company providing smart solutions for spatial projects. We've been working together with Calvin and SBI for a while now already on innovative projects. Calvin mentioned we've been working in Estonia for a smart solution, but together with Calvin and some other people, we've been also working on implementing an openBIM, openGIS solutions in Hong Kong. So that's where we've met and already collaborated. And as you can see over here, a quick introduction. What are we doing? Building smart solution. So you see there's a GIS functionality on the left. You see clearly project, which is a collaboration platform for spatial infrastructural projects, where you can combine all kind of data on the map with also workflow and documents. And this way really have all the stakeholders working on such a project, really have one central point of truth and start collaborating over there. We typically have contractors, engineering firms as customers for this solution. On the other side of the spectrum, we have digital twins, 3D digital twins in 3D City. Those are cities like City of Rotterdam, The Hague, and we help them with the infrastructure, the technical infrastructure to set it up, but also to maintain this kind of data. What we see is that more and more cities are starting to add a 3D map next to that 2D map, but also like Rotterdam is really aiming at replacing their 2D map with a 3D city environment, which you can use for all kind of smart solutions, flooding simulations, public participation, all kind of stuff. And it's not just the buildings, it's also the tree, underground utility networks. So more and more information is becoming available like that. And good to mention is that everything we do, all our solutions are web-based, using open APIs and international open standards, like the BIM standards IFC, which Ian just mentioned. It's really important. We see that more and more of these smart solutions, if you want to connect them and combine them, you want it to be open, because that way, in the end, you will be more flexible and can start combining all these different solutions. So I'm going to focus a bit more on the clearly BIM. I saw in the program BIM-GIS integration. I think we're pretty good at that because we kind of we know both worlds pretty well. So I will show you a little bit more about our Estonia use case, because that's a nice one. Our new clearly BIM solution, which is based on that, and then in the end, as Kelvin mentioned, a short demo to really show it, because in the end, slides are nice, but showing is better. And since it's a workshop, so I'll try to go through the slides quickly because we don't have too much time. And if there's any room for questions, it would be nice. So really quickly, the Estonia project, that's where we kind of started our BIM solution. We already had some experiments, but therewith we got the real question. So the question was build a BIM-based permitting solution, which they can use to semi-automatically handle their building permit process. So based upon a BIM design, and this is a building. I know the public is more infrastructural, and we think this kind of solutions now with the new IFC standards, Building Smart is implementing now, this kind of solutions will also become available for infrastructural projects when we adopt the new IFC standard. So uploading a BIM file as an architect to the central governmental website, where you can just upload the file. Automatically it's put into a database, it's processed, and then automatically also all kind of checks are executed regarding permits. And you get immediate feedback visually, as you can see over here. On the left top, there's a list of checks which have been executed. The green ones are okay, the red ones have an issue. And then if you click on it, you get a result. So some examples, the left top, every apartment above the 4th floor of an apartment building should have access through an elevator. In the green, you see the apartment. In purple, you see the elevator. So apparently this one is okay. At the right top, you see a fall detection check where it checks if you can fall off high rises. So here we've removed the handrail from the stairs. And as you can see, you can fall down. It's red, it's detected. And this way you can automatically define all kind of checks. And maybe the right bottom or right, the low one is nice. It's a fire safety check. It checks if the maximum length of a fire safety route is not more than 30 meters. So here you can see the line where you walk through, and this one is also okay. So this way we can set up all these kind of checks. And what's important is that since we do it online and everything is through a really simple to use user interface, we're not focusing at the traditional designers who already know BIM because they have tools and they can do some of these checks, not everything, kind of by themselves. We focus on an entire different audience. So the stakeholders in your project who aren't that technical, who only use PowerPoint or Outlook. People in the permitting process who also don't have the technical background. There's a lot of people who should have, who would be really helped to have this kind of solution, but it's way too technical and complicated currently. So by putting it online, we can integrate it anywhere. So in Estonia, for example, it's integrated into their nationwide permitting system. and it will be available for every permit handler within a municipality within Estonia, but also for all architects, developers who apply for a building permit. And once they upload, they can just check it themselves if it fits to the permitting requirements. And if it's not okay, they can download the results themselves, fix it, try again. And once everything is fixed, then upload the design, which is of course a huge time saver. And it's also much more objective than some guy who is also having a look. So on the right, you see a small list of technical open standards we're using, both from Building Smart as the Open Geospatial Consortium, who is similar to Building Smart, but then responsible for the geospatial standards. And these standards are used all around the world. So the nice thing is that the solution we have made, you can use it anywhere. And the case we've built for Estonia now, we're also trying it in Finland currently. We're talking in the Netherlands. So you can configure and adopt you can change and fill in the standards for your own needs, and that way use it anywhere. And that's really cool because based on that, on the right, there's Ian again. Hi, Ian. Good to see you again really shortly. Last year, we've won the Building Smart Award with our solution, especially for the scalability and also the impact, because the whole new target stakeholders, the user group we're focusing on, because there's a lot of added value and time savings, potential time savings over there. So far, the Estonia use case, now we're running into Clearly BIM, our solution, where we took the solution we kind of made for Estonia, made an entire new solution, which you can just use out of the box. It's a web-based solution, so you can use it anywhere. It looks similar, online solution, using openBIM, so we're really focusing on that, because then we can use it anywhere. Automated checks of the BIM models against requirements, and executing all kinds of checks. We can combine it with the digital twin. I will show you a quick example later. We can export to all kinds of models, so you can use it in other places. And we can execute all kinds of checks, both IDS, which stands for Information Delivery Specification. It's a new standard from Building Smart, which is almost final, I think. Because it's really important, especially as a government or as an asset management system, you need to have these files predictable to be able to have it work. Otherwise, you get different results all the time. So it's important to set requirements how you exactly want these designs to be made, because then you can start automating everything. And then based on that, we can execute all kinds of checks, permit checks for permit application. In the Netherlands, we have been playing around with some house numbering processes, but also environmental checks. In Finland, we're working on some CO2 checks. Asset management, you can use it for all these kind of systems. 3D cadastre, we've been working on that, 3D ownership. The BIM files are all a really good base for that. And by making it online available with an API, making it much more flexible, you can start thinking about these solutions. And because we have this integration, you can also, this is a nice example, the city of The Hague. So you see the digital twin on the left, and then you see a new railway station, which we have separately stored in our BIM database, but we can also show it within the digital twin. So that way you can start showing new developments in the surroundings. This is all still buildings. So let me quickly show you with a short demo of, this is a recent project, which we've been currently still working on. The province of Zeeland. You probably all know in the Netherlands, we're really good with water. This is exactly one of those things. So a big bridge of 5 kilometers, which connects two islands within the province. So here you see Clearly BIM. It's online. Let's see if it still works. Here it is. And here's the Zeeland Bridge. Um, it takes a little bit longer than regularly because I'm also sharing my screen and I have the chat button in here. And it's a huge bridge, it's 5 kilometers long. So typically BIM solution work for buildings until now, especially with the open standards. So, but as you can see, this one is taken from an aerial point cloud. But the province is looking into using this for their asset management, adding sensors to it, so that way you can much more easily predict when maintenance has to be done. And you see the huge pillars which have to be underground. The whole check thing doesn't really work yet. We haven't configured it yet because this is still work in progress. But one of the things I can show you here, where is it here, is we can also show the surroundings within the BIM solution. But because this is, it's a huge thing, typically BIM is for a smaller area. So here we typically load a kilometer of surroundings. Now it's only sea and water. So typically BIM solutions aren't really good at this part, but that's where our knowledge of the digital twin comes in place, because we also have digital twin. So here you see the digital twin of the Netherlands, and here you see the bridge. So we just project, this is not converted, so we just take the BIM design from our database, project it in the area, and now we can combine it with all our geospatial information. And here you see it's really, Netherlands doesn't have much elevation, so here are some dikes which give some elevation, and it fits nicely within the surroundings. We can also turn on, for example, the properties, the cadastral map, so you can see we even have zoning plans, which are typically a bit slow. But this way we can, you can combine all this information and see what's going on. But a nice thing also is this is the entire bridge, which isn't that detailed, but we are currently working on the more detailed part of the project, especially for this asset management part. So here you see kind of the geospatial version of the BIM design. So it doesn't look that nice yet. It's slightly simplified, but you still see over here the railings and everything. But now when I click on it, there's a link, and when I open this, we've integrated the web viewer. Again, this will be slightly shown since I'm also showing my screen. And now it loads the real BIM design, as we've used in Clearly BIM and as we are doing in Estonia, because we can use it anywhere. And now you can also click on it, and you get all the information for this property, for example. It's in Dutch, but it's a bridge deck. And now we can start integrating and really use it for all kinds of applications. So this way we can really combine all the stuff. This is also exactly what we've been playing around with, for example, together with Calvin in Hong Kong. And it's getting more and more mature. So now it's a lot of buildings, but I think especially now with the new standard IFC 4.3, all this stuff will also be much more applicable to infrastructural design, to road designs. And then you can do exactly the same thing. And especially the web-based, making it available web-based in a really simple solution for a much broader audience, I think is really powerful. Yeah, so I hope this makes any sense to you. And then I hope I'm kind of in time. Let it be an inspiration, think about it. If you're interested, please contact me or us. Dennis will be later available through the Q&A as well. Thanks for now, and if there's any questions, yeah, let us know. I don't know if we're still online.
Yeah, we hear you, Rick. Thank you. They're just organizing in the room.
Oh, okay.
Indeed, we are trying to unmute ourselves. So thank you. Thank you. We're all paying good attention, listening to you, and forgot how to unmute for a minute. So good. I see that there are some Q&As in the chat window, but we would propose that we quickly hear from the other three presenters, spanning from other parts of Europe, and then we'll have a discussion together. Supposedly, if we go on time, we should have 30 minutes for discussion and Q&A for each session. So thank you. Thank you, Rick and Future Insights team, for us to learn more about Digital Estonia, Digital Netherlands, that cover not only buildings, bridges, but really Digital Netherlands. So next up, I think we are going north to Finland. So joining us from Finland, it's Jiri. Jiri is joining us and will tell us more about what they are doing with Finland government, with Scandinavian governments, using openBIM, serving both infrastructure and building projects. So the floor is yours. Jiri, thank you for joining us.
Thank you, Calvin. Can you hear me?
We hear you well.
Okay,
would you like
thank
to
you.
also turn on your video? It's optional.
Unfortunately, it's a bit late here, so I am at home, so I don't have my camera on this setup.
Thank you for joining us late in your evening in Finland. So thank you. Go ahead. The floor is yours.
Okay, thank you, Calvin. So about normalizing infrastructure openBIM. My name is Jiri Hietanen from Finland, and I come from a company called Datacubist. And we are a software company founded in 2009. I myself am by training an architect, and I started the IFC, working on IFC in 1997. So I have quite long experience already before we founded this company with my colleague Sakari Lehtinen, a structural engineer. And we basically saw that there is a gap. There is like, we try to solve data exchange problems in the building industry with the tools that we already have. But if we open up and think about what kind of tools we really need for solving these problems, then we come up with completely new ideas, and this is what we are doing. So we developed Simple BIM, and we have it as a desktop application normally, and as a cloud-based solution. And we are mainly working in Europe, but have resellers in this area, but we also have a few customers in the US, Australia, Japan, and so on. So today, very shortly, I just want to convey a simple message that you don't have to worry, and you can start with this openBIM normalized models today. And when you start today, you will be just fine tomorrow. It's a future-proof solution, and there is really no need to wait for something new to happen before starting. That's the main message. So the example case, seeing is believing. It's a bridge here in Finland. It's here in Western Finland, quite long bridge, about more than 1 kilometer long. And what you see here is an IFC model of this bridge from the year 2014, so around 9 years ago. And this model is in the old IFC format, the IFC or version 2x3. And now if I switch to the actual model, do you see the model here?
No, Jiri, I think we're still seeing your PowerPoint slide. Maybe you have to set it so that it's showing the whole part.
So thank you. So maybe now.
Yes, we've got it now. Thank you.
Thanks. So I have to switch. Yeah. So because this is seeing is believing, so I think you would like to see the actual model so that you can believe. So this is the bridge, and these are the parts of the bridge. For example, this one is a pylon. So from the IFC viewpoint, from the technical viewpoint, which we don't care so much about, it's a column, but So there are no bridge parts, there are no pylons, decks, and other bridge semantics here, but it doesn't matter because each of the objects knows what it is. So if I zoom closer, for example, to this deck, we can see that this is the surface in Finnish. This is the surface of the deck. And here even we have some the bolts that fasten this railing to this side beam. So every object knows what it is in terms of a bridge. So it has the bridge semantics, even though IFC doesn't have it in this version of IFC. So this is, and this model is really from the year 2014, and all this data in it is from that year. So if I change back to my presentation. Okay. So what happened in 2014? We participated in writing these requirements for bridges for the Finnish Transport Authority. So they are anybody who is designing bridges in Finland, they're supposed to deliver an IFC model of the bridge that follows these guidelines or these requirements. And the idea is that these models, they contain the necessary geometry and data for bridge maintenance. So the idea is that these IFC models are submitted to this transport authority, who is then importing the data from IFC into their own bridge maintenance system. And of course, keeping the IFC as well. So the only things they really need is the properties. So you can see here the properties of this pylon in Finnish, and I translated them here in English. So we have material, frost resistance, surface treatment, and so on. And the important information, what is this object representing? So this one is a pylon. Then the second really important thing is to have is a list of allowed values for each property. So you can't just have any values. So you have certain types of elements, you have certain materials, and so on. And all of them have a list of allowed values. So it's about the data. And then they have finally some dependencies. So for example, if this part of the bridge is made out of concrete, this K50-1 is a concrete class. If it's made out of concrete, then in our climate, it must have a frost resistance. But if it's made out of steel, then it doesn't need a frost resistance. So these values have some dependencies like this, so that they can be evaluated. You know, is this valid? Is this a valid model as an input into this bridge maintenance system? And we have these rules, but it's not more complicated than this to have very useful data. And then, sorry, I'm going very shortly into the IFC stuff, but I try to keep it really simple to make a point. So this pylon that we have in this model, it's an IFC column, but we don't care about that. What we care about is that it has this information and that it is in this old format. And then we get this nice new format, IFC 4.3. And there we have an IFC bridge part, which is much nicer than the column, but it's more to the point. And it has a predefined type pylon. So what really changes in this new version is that, well, it's a little bit nicer. We have a more fitting IFC object class. And then we can drop one of the properties away here if we use this one. But otherwise, you see that it's really the same. There is no much difference. So if you are doing this today, and you have the solution for converting it at any time, then you can tomorrow have the IFC 4.3. So you don't have to worry about the IFC version. You just have to worry about the data. And this is how we convinced also the Finnish Transport Authority to start already 9 years ago, because they were worried about the same thing. Is this future-proof? Can we start now, or do we have to wait for something new in IFC to happen? And we convinced them that no, you can do it today. And anytime you need it in a new format, when the new format appears, then just convert it and you're fine. So the important thing that you need to know is that it's about the data. So you're fine if you make sure that you have the same data in the same place with the same values in all of your models, because it's no good if every model and every project and every time it's different. That's a bad situation. But if it's the same every time, then you can make this kind of conversion from the old to the new. And it also makes the data much more useful in your own systems, because you can write logic that, for example, searches what are the bridges where we are using certain concrete, for example, or certain types of components, elements, and so on. And you also, the standard will never cover everything you have in a bridge. They can try, but it will never happen. For example, in Finland, we have, in many of the bridges, we have this compartment where we put the explosives. And if the Russians come over the border, then we just blow up the bridge in a controlled manner. But you probably won't have that kind of object in your bridges. So it's about the data that you need and how you capture that data in the model. That is the point. So you can start today, and tomorrow you will be fine. And because you have a normalized model, normalized models mean that the models meet these criteria, and it's no more complicated than this.
Just to let you know, even though we were muted, Jiri, we certainly reacted. We certainly reacted a lot, as you could hear now. Yes, right. just to say that we are not only with you, but we are really with you. Yes.
All right. Thank you.
So please continue. Yes. Yeah. We are following you well.
Well, that's basically it. It's because it's simple, it can be short. So thank you. And I'm happy to answer any questions then in the Q&A session.
Great. So hold on to all the questions. Let's give both speakers a round of applause. And then next, we are going to transition to a hybrid presentation to go from Finland to Norway. But speaking about Norway, we'll be having a joint presentation by Steinar right here, currently as a PhD student here at Stanford. Sorry, let me welcome my deck. And also Katrin joining us from Europe today. So just do a sound check. Katrin, are you with us? Can you also speak to us? Oh, I need to do a screen share.
Can you hear me?
Yes, we can hear you. We can see you. Yes. Hello, Katrin.
Hello.
Now let me do the screen sharing, and we also be broadcasting Steinar's face. So looking forward to it. A hybrid presentation, Stanford and EU talking about Norwegian infrastructure. So just one more second. I need to get us to be broadcasting to remotely. All right, the floor is all yours.
Thank you.
And I have the.
Thank you. Yes, I will start. My name is Katrin Johannesdottir. I come from Iceland. Worked in Norway for many years. Been at Trimble for the last 2 years. Before that, I was 11 years on contractor side. My background is geomatics. I did civil engineering, geomatics, and technology management, which I then later on combined in VDC and did the certification from VDC in 2017. 18, and then mentoring. I'm actually doing my second year of mentoring this year.
And then it's Steinar. I'm a PhD student here at Stanford. My history is I started working in a company that was bought up by Trimble. After I left, I worked as with 3D BIM earlier in 2008, 2009. And then I went into consulting and was there some years as a BIM expert. And then I learned about VDC, came here, did a VDC certificate program, started as a general contractor, learned all the mistakes I've done. And we're going to talk a bit about that today. And why I'm saying mistakes, I want to start with this picture, because one of the things I was teaching when I was working in the software developer was that we need to actually deliver what general contractor needs. And as you see on this picture, it's a cross section of a road. But you see that on the, if you drive on the embankment, you will not have the bearing of the road. So you will actually have, this is not how you're going to construct a road. And the discrepancy here in the industry was that consultants will believe that general contractor will fix it. General contractors thinking that consultants are not doing their work. They're actually just delivering the topsoil and not really what we need to build the road. This is what you need. You need to actually have the bearing of the road, and you actually need to have, this can actually, I've had some projects where they actually gone into the zoning plan of the project, where we have to do a lot of extra work because we are not aligned on what we need. So to design what you build and build what you design is one of the things we want to go into in this presentation. We will go back a bit in history, how we have developed in Norway. Katrin will talk a bit about BIM, and I will go into a bit of VDC part. So we start a bit with the mans from owners. Then we go into the ICE, how we utilize integrated concurrent engineering, one part of the VDC. VDC. And then I will go into what we are doing in Norway today. And then I will talk about how we are developing VDC in Norway. And lastly, I hope I talk a bit about my research here at Stanford. So, Katrin?
Yes, thank you. Yes, demands from owners in Norway. If you go to next slide, there are a lot of money used on infrastructure because every state spends most of their budget on that. So you can imagine that they did test or investigation, the Public Road Authority in 2006, where they found out that this deviation of the contract price was around 24.9%. Which is a lot. The politicians can talk their way out of that, but we as engineers, we had to find reasons like what can we do to actually fill that gap. So we go to next slide. Finding reasons for or suggested solution to reduce the errors. They saw that the as-is data, or we talk about data that shows existing situation in the projects before they start the project, they need to have quality requirements or quality data on that. They also needed to require 3D modeling instead of drawing production. They wanted to have, they made it really clear requirements on documentation in each project. And focusing on standardization. So all documentation would be standardized and possible to compare to from project to project, as well as the documentation should actually provide data that would provide better plans and better implementation in the projects. It's not enough to say what you want. It's important. And I think one of the most important success factors in Norway was that the Public Road Authority and Public Railway Authority, they actually got deeply involved in creating manuals to drive that digitalization forward. So in 2011, they started the draft of that manual 138 called. And the Public Railway Authority, they had another manual that they published in 2012. In 2012, that manual that was drafted the year before became public. And at that time, we have a project. I'm working for Skanska as a BIM coordinator on a project in downtown Oslo, which was the pioneer project for 3D model-based design and construction. In that book, that manual, it stands in one place that if there's a mismatch between drawings and the model, it's the model that applies. That was really important. And I remember at my office in Oslo that I actually printed that out from the handbook. I framed it and I put it on the wall. And I stayed at that project until we finished in 2015. So if people were asking about drawings, things like that, I just pointed at the wall where we had that from that book. It was really important that it was in the contract that the model was, the right answer was in the 3D model. And that book or that manual has been developed until 2V770 continuously, and it's still under development. Next. They had been doing modeling, started earlier with that. So those, this is how you can see the results. They were analyzing, VNO Systems and the Public Road Authority were analyzing difference between the normal road projects and model-based design. And you can see how the difference is when you use BIM methodology, that you have a lot less errors and soon less change orders. Next slide. Yes. In 2016, there was a change in Norway. The government started a company or a department called New Roads. It was also working, it's governmental, but it's also working on public road projects. But since it was a new company or new organization put together, they were proving themselves as well, and the Public Road Authority got a little bit push as well. They focused on different kind of contracts. They went to many of the design build contracts. They did a lot of IPD contracts or some IPD contracts and new methods. And they are still now in Norway, but they really pushed the limit. I remember when I went to the first bidding on a project from them, they were asking about, they were really pushing the contractors and the designer on digitalization and value-based digitalization, which was fantastic for us that we're asking for this for a long time. Next slide. And now Steinar is going to tell us a bit about ICE in Norwegian projects.
ICE is one of the elements in VDC. And when you have a possibility to execute projects, we were back in 2015. I see there's something wrong here with the formats in the copy here, I see. But this is a zoning plan from 2014 to 2016. 10 kilometers of a double track in Norway, a railroad track, and a station. So at this point, I was doing my master thesis, 2015-2016, and my colleagues wanted to look into ICE, so we hosted an ICE session together. And the problem was this area. We want to have trucks going down in the winter to be able to change the transformation station that's in that big room. You need to have both a road, construction, architect, water sewer, electrician, a lot of different disciplines agreeing on the solution of the project. So we started the meeting. I informed what we're going to try to solve. We asked one of the guys to actually be prepared for the meeting. So he came in with 3 suggestions of what is the solution for our project. And what you will see when I give the introduction, quite shortly, the people are gathering around the construction guy that had made the 3 suggestions, and they start discussing those 3 suggestions. It was one of them that we developed further, but I actually start discussing those. What you also see is that the road engineer goes back, checks his longitudinal profile. How is this actually aligned to his ability to get on a truck? The architects go back and check what is the architectural of the building, how will this look? What is everybody was working and discussing and trying to figure out how is this actually working. A regularized meeting, you discuss, you try to design, you find out how can this actually work. Interesting with this meeting was the first IST meeting we had. Everybody had 2 screens. Then it would never have only the laptop. They wanted to have really working desk and be able to verify the design. When we agreed upon the solution, they sat down and started doing the engineering because we didn't want to let them go and leave the room. We want to make them actually prove that the solution was valuable. So lunch, the construction guy did not leave. He only had 5 minutes for lunch, but we came back. And what happened is that we invited a manager. He should, of course, have been there from the start. He wasn't able to because he has a meeting with the owner, I think. But he come into the room to see the solution we have and get information on what we discussed so he could present it to the owners, to Bonnenhof. And that is how we ran the session, that we were actually able to utilize the people, their expertise in a nice meeting and just actually solve the problem. So you see here it's approved and we're still running around and discussing. And some people didn't want to leave, and we had actually this time we had a lot of people coming in to see how we were actually working in that project because it was new for the company. I was working at a company called Sweco, it's a consultant company, together with the Trimble. So this was a quite fun project to do. What's interesting is that something that usually takes 5 weeks took 5 hours to solve. Of course, how much time of those 5 weeks I haven't looked into, but the problem would be 5 weeks to solve, and you would actually get a not as good solution. So it's that setting the right people together is what made us get a good product. And this was changed to a bid, design, build contract after the zoning plan. So I don't know what was built at the end, but it's lasted for many years, the solution we made in that meeting. So how is it going today in Norway, Katrin?
Yes, we have those from both Public Road Authority and Railway Authority, talked about earlier, those handbooks and the webpage or the project, which is called KIM, which is Demands and Model from the Railway Authority. And also we do also manuals that are like in the industry. And this is, I think, really important that we do industry manuals where people that are working in industry, they're working outside in projects, where they come in and they describe how they work and they find best practices and they make manual out of that can actually guide the others. That's how we made the MMI manual. And we are at the moment working on a VDC manual or guidelines for Norway. Next. The demands and requirements today. We have the models, they have to be contractually written in the contract that they rank above drawings. Next, the surface data, the quality ground surface data, it has to be of good quality and accessible. Standard formats, we're focusing a lot now on IFC 4.3 for infrastructure, and structural data and open APIs are important. It has to be a requirement that we are doing 3D model-based design for all disciplines, so we can put them all together in one 3D model. Also using MMI, so it makes the project easier. We have the multidiscipline collaboration model, so we can do clash control, so we can find the everything that's wrong with the model before we build it, find the mistakes in the model and not outside in the field. And we're able to use the data, construction data. When I talk about construction data, I mean data that you get out in the fields, that earlier drawings, you get surveying data, you get data for the machine control. All those data have to be constructible and directly from the 3D model. And you have to be able to adjust the aspect for future maintenance. As I said earlier, we are focusing a lot on IFC 4.3 now in Norway. I work for Trimble. They're focusing, like all the focus now is getting IFC out. And that's for infrastructure, to structure the data, the objects, the property sets. And there's the inheritance or the connection between the data and the data structure. Next.
I just want to take up this picture. I've been working in the industry for 14 years. And one of the issues I had in past with IFC is the stakeout data that we don't get when we produce a model, we get a 3D geometry. We don't get alignments, for instance, for pipes, for manholes, those kind of objects, the alignment. This is back in 2020. Oh, I see it's something here missing. The images are stretched a bit, but this was done in 2020. IFC 2x3, and we got from the program, they started delivering the lines. So actually in that project, we were able to get stakeout from in the IFC file and could use the IFC file for stakeout, for machine control, for everything. So instead of having 3D or DVGs or other type of format for stakeout, we could use the IFC file. But that is a change that has been in the last few years. And that's the software developers that have developed their software further. So a bit about VDC in Norway. We are now hosting courses in Norway because ICE, BIM, PPM, those elements of VDC. We are hosting every year trainings together with Stanford. So me and Katrin have been mentors. Katrin is current mentor, and I'm facilitating this course together with Stanford Continuous Education and Antonu. We have certified around 200 people a year. So just to show you that development, I was in 2016 at Stanford and did my end certificate in 2017. Katrin took hers in 2017. We were some of the 100 first in Norway to take it. And now it's over 800 that's getting certificate. And we're also doing mentor certificates together with Martin. To end a bit, I want to just talk a bit about my research, why I'm here at Stanford. One of the issues I've seen in industry is how we actually work on a project as a designer, as a general contractor, how we actually execute our project. Are we focusing on the right targets? And do the people, participants in the projects actually know what is the end goal for a project, either vertical or horizontal? It's really not a consensus, as far as I've seen, on what performance metrics to track during the operation phase of buildings and infrastructure. How can we actually bring that back and then use it during design and construction? So this is an example from a project I was on. It was presented here at the summer program some years ago. I made it a bit easier to read, but they actually looked into what is, you have one that's buildable, that is built, the building can be built. But then you have cost of operations and cost of execution. You have CO2, you have different elements that you want to actually look into the future and evaluate your options. So they actually did that based on metrics and actually were able to then do the correct design of the project. So what I'm going to do at Stanford, my research is focused on, is actually, first year, is actually making a list, a sorted list that is quantifiable and prioritized. So we actually have a list that we can use in the future to actually make those, what is the operational metrics for a project at vertical or horizontal. So that was the last slide from us. Thank you.
Well, thank you. Thank you, Steinar. Thank you, Katrin, for sharing with us the perspectives from Norway and also the tie between Stanford and Norway over the years. So thank you. So indeed, I think both Steinar and Katrin mentioned about the VDC culture or the VDC definition that was born at SciFi 20 years ago. Term or the idea about product modeling has been around for probably 30, 40 years or longer. But then in terms of BIM, in terms of VDC, those definitions really came out, in particular VDC, from Stanford, from SciFi about 20 years ago. And so the definition of VDC is that how we can leverage BIM as the product side to represent what the model is about, the product is about, but also to bring in kind of like the process, the production mindset, with kind of like how do we bring lean, how do we manage the supply chain. Then with the ICE, I think the term ICE is what we've been learning from NASA, JPL over the last 20 years in terms of how do we turn months and months of kind of like aerospace planning into weeks. And we're very happy to actually see that with Norwegian infrastructure projects. And then, but most importantly, also connecting to what Steinar was showing towards the end, it's how do we report that, quantify that, prioritize it. Not only in terms of typical project metrics, yes, we want it to be safe, to be on budget, but what may be the ultimate client needs, what may be the ultimate public good that we want to do, which is what the client objective is about. So the other relationship is that Building Smart USA in SciFi have been reciprocal members since since Building Smart USA was formed, and also a lot of what they talk about, the courses, the professional courses, are now also going through Building Smart International management courses. So hopefully we also see more blending between the SciFi education and the Stanford SciFi SCPD education, and also what we are promoting globally with Building Smart. USA and Building Smart International. So having gone through quite a tour of Europe, let's also do a little bit of hybrid by welcoming Katie Pond, to be joining us in person to also talk about another great Stanford relationship with Alice, and also what you have been doing globally with infrastructure.
Wonderful. We are actually going to stay in Europe for the most part, even though I'm based here in the Bay Area. Good to meet everyone. My name is Katie Bond. I oversee global deployments with Alice Technologies. And today I want to share a story of how we've been able to apply this technology in the real world with a project funded by HS2 for the high-speed rail in the UK. So nice to be back here. Alice actually was born right here in Stanford out of SciFi. Our founder and CEO, Rene Morcos, conducted his PhD here. The area of his research was really looking at the efficiency gains in the manufacturing and operations space and asking what would it take for the AEC industry to be able to adopt some of those similar practices and really leverage data and simulation more than has typically been the case. So that was back in 2013. We've come a long way since then. I won't bore you with the company metrics, but what Rene ultimately built and what Alice does today is construction optioneering for capital projects. For us, optioneering is being able to ask what-if questions of your plan, of your project, and get real, meaningful answers that can help you drive decisions. What if I add an extra crane? What if this crew works overtime? What if I want to try method A versus method B to construct a certain piece of the scope? In the past, that was really something that you just kind of trust people's instinct, trust people's experience, maybe sit down in P6 and spend a few weeks to come up with one good alternate scenario, but you're certainly not able to ask many questions rapid fire to come up with the best plan. So how do we get to the point where we can have a simulation and ask these questions and get realistic answers? This may be familiar to everyone in the audience today. We start with the model. I will get ahead of one question. Does it compatible with IFC? I have to wince. We're actually built today with Autodesk Forge as the viewing platform, but we do have a lot of customers. In fact, the case study I'm going to go through today was an IFC model. It's something that we just could do a little conversion and bring it in. I'd love to support it directly. We're really looking at the market and demand for that feature and seeing it grow over time. So we can use IFC here, but we're not as strong of an IFC solution as many of the other presenters today, I will admit. We start with the model, and then we unite the model with the schedule and with cost.
we're putting all of these things together by doing what I call element-based planning. So each of those BIM model elements now gets a recipe attached to it, which is the series of tasks and the resources required to complete those tasks, as well as production rates for those tasks. What we're doing actually here, if anyone has generative design background, is we're parametricizing the entire project so that you can now iterate on those parameters. So we're defining the rule set here. Then it gets to the fun part. Once you have the elements associated with recipes, you have a simulation. You can do 3 things once you have a simulation of your project. First is de-risk. You can really just hit fast forward on the reality that you believe is going to happen today. Does it end where I want it to? How do I land on cost and duration when I hit fast forward on the plan? There's a lot of risk that gets surfaced and can be addressed at that phase, usually far before the first shovel has gone into the ground. After we de-risk, we can also optimize. This is where I have purposely not used the term AI yet in this talk, but it is an AI application. We don't talk about that as much because people have a very charged reaction to AI sometimes, but look, ultimately it's a search algorithm. It's doing this massive Rubik's Cube solving of all of the resources available, all of the constraints of your project to find the fastest or least expensive, or name whatever you want to optimize for. It will optimize for that and find the most efficient solution. What we'd see typically is that 10 to 15% faster and cheaper than a baseline schedule generated from traditional methods. So we talked about de-risk, optimize. Then the really fun part is the what ifs. So a lot of people have immense creativity, especially people who've been building for a long time. They have hunches. I feel like that part of the schedule is a little fat. I feel like there must be a better way to bring these scopes together. And with what ifs, those experienced users or even newer people can start throwing those questions at Alice and get answers in minutes. It's about 30 seconds of effort and about 8 to 10 minutes of computing to get a resource loaded full schedule and simulation that has twisted the parameters that you're curious to twist. And then sort of the last phase is using that to drive an action and decision in the real world. We don't want to stop with having an interesting dot on a computer screen. We want to stop when we've applied that insight and improved the way that we're going to build a project. So that's how it works in theory. Let's talk about a real world example. So I mentioned HS2, $100 billion project to bring a high-speed rail connecting London to all points north through the UK. Really expensive, really massive scope. We got involved with one of the JVs, a line JV. It's actually composed of Bouygues, Sir Robert McAlpine, and Volker Fitzpatrick. They're doing this awesome scope. There's a tunnel, there's some road, but the part that we got really involved in was this viaduct. It's about 30 kilometers northwest of London, and it's on the critical path, not just of the Line JV's scope, but of the entire $100 billion project. Getting this viaduct right is very important. And so they brought in Alice. We came in actually far after the baseline had been set. We came in about 3 years after the bid had gotten awarded. I think they'd already started to do some of the mobilization work, but they hadn't started the project in earnest, in execution. And they wanted to see if they'd left any money on the table, so to speak, any opportunities to make the project go faster or cost less money. The headline is the Align JV team using Alice technologies to simulate and run what ifs found an additional 4 months of savings, which anyone who's ever built any capital infrastructure project knows that is just massive. Whether you use that to actually turn your project on 4 months earlier, or whether you use that as padding and buffer and float for other unexpected issues that could arise with your supply chain or other parts of site logistics down the road. So how did we do it? I'll give you the answer. It wasn't just letting the AI run and optimize and squeeze things that the humans miss. There is a little bit, you can always find a little bit with AI that way, but really I have to say it was the experts on the Align JV project in the room who had a lot of creativity, who had a lot of experience, ideas they wanted to test that in the realities of a project that's about to go into execution, no one has months to wire up another entire P6 to try to resource load it and see what could work. No way. So we had those experts in the room, we built the simulation together, and they started throwing their wildest ideas at it. And the idea that ended up being the most impactful was the way that they were going to create the material for the viaduct. They were able to, they had an option to do it prefab or to cast in place. And how does this work usually? People sit in a room and bicker on gut feeling and instinct. No, I think this is the way. No, I think this is the way. I saw this word before. No, that's going to be a huge problem. And it just kind of becomes this lively conversation, and then someone gets their way and off you go to build it and hope that those hunches were right. We tested it. We ran the numbers. We threw in a version of the simulation with cast in place and a version with precast 1. It was actually really neat for me. I went to the site, I visited, I spent time with the team as we were doing the precast versus cast in place simulations. I came back a year later and the most massive, amazing precast factory was just right where there used to be empty land. I was like, wow, it's so cool to have been part of that. But that and a few other optimizations added up to 4 months of savings. What I think is cool about this, and the quote I wanted to highlight here, was one of our internal champions at Align JV, innovation manager, Nick Podevin, saying, look, this opened people's eyes to the way that AI can be applied to construction management in the real world, right? This isn't just some space age technology. This is something that we're using to test ideas and find actionable solutions in the real world. So all of this story that I'm sharing happened a little over a year ago, and I wanted to share what's happened since then. This is a fun one. Last October, Align JV and Alice together were awarded the British Construction Industry Award Innovation Champion Award. So it's a fun photo here. I unfortunately wasn't there. I was here in the Bay Area, but some of my colleagues were able to go out. And what we've ended up doing since then with Align JV is just moving that focus lens of the simulation further down the project. So as they've now decided and started building the deck, moving to the next scope and to the next scope, right now we're trying to help them land the plane, right? And make sure they keep all of those savings of duration and cost by getting the landscape and demob nailed. So that's what we're up to today. And in closing, I just wanted to share a few learnings and predictions. I think this is a really exciting audience because we have people on the academic side, we have people on the asset owner side, people on the GC, the technology. So maybe I want to seed a little bit of conversations here. Come find me during lunch or on LinkedIn for the remote participants. But something I see is that owners and GCs are looking for a more collaborative relationship, but what's missing from that is a shared source of truth. The BIM model is a huge part of that. And I think technologies that can then be built on top of that model, such as Alice, are another big part of that. But it's really hard to collaborate when your data is different. Historically, I feel there's sometimes a bit of a poker game of who knows what with what's going on in the project, and kind of moving past that to a shared source of truth is going to allow for that collaboration that we all want. I think owners have a critical role to play in creating the environment for innovation. In this Align JV example, the hidden star here was actually HS2. It was the UK government. They were so innovation friendly. They helped with the funding. They set up the expectation of, hey, we're here to learn together and try new things. We're not going to, punish you if you try something new and it's not perfect. We're going to embrace that you did that. And we're going to ask that if you find something that works, you share it with the other JVs in this consortium, because we all are working together to bring this $100 billion scope to life. That was great for us because since this engagement, we have started working with some of the other firms within HS2 and actually also with HS2 directly to do some program level optimization. What we're seeing from the ALICE side is that when it comes to public infrastructure projects, Europe is really in the lead as far as owners creating that environment that supports innovation, encourages people to take risks. When it comes to private assets, we're seeing North America in the lead there. Those private owners, whether they're building data centers or manufacturing facilities, they're really the ones that are pushing their GCs and encouraging and supporting them to try new technologies and not punish them too badly if it's they take a risk and it's not perfect the first time. And then lastly, I think a lot about mutual incentives, right? We need to work together to create incentives so that we all win together across the supply chain when we are able to build more efficiently. Not winners versus losers or one person hogs all that benefit, but how can we really move to shared incentives and use that to create mutual commitment and get over those learning curves and humps that go with that. So that's the end of my presentation. I'll just share for anyone here who wants to talk or learn more or nerd out on generative construction with me. I'd love to talk about it. Thank you.
Thank you. Thank you, Alan. All right. So thank you. So what we hope we can frame the Q&A and the discussion in the upcoming minutes is that we have seen lots of proven examples, ongoing progress from Norway, Finland, Netherlands, UK, Estonia, just in the past hour or so. What can we in this community, in this room, in this virtual room, do together if we were to move the needle a little bit between now and say the end of the year? And if we can adopt some of these proven examples, or if we can change something and come up with, say, an American way or a BSI way of doing something, what can we do together? Can we team up with some of these partners globally, learning from Norway, learning from Finland, learning from many other friends in the world, working with Building Smart, working with Stanford, working with all the communities? What can we do together to move the needle together? So let's see if we can frame the Q&A on that. So Tony, my colleague Tony Winella, also a volunteer leader with Building Smart, can you maybe summarize what we see with I think we have about 70 people joining us online, and there was some good interaction. So Tony, let's go ahead.
Yeah, thank you, Calvin. Maybe just a couple of sound bites from each presentation. One thing we heard is using open standards and open APIs is actually working to merge geographic data with BIM to perform various kinds of analysis. And it can be used not only for design, but also for asset management and maintenance prediction. Very important for infrastructure for sure. We also heard from Jiri, using detailed models for construction and management is viable. That governments are also recognizing that this is critical knowledge and needs to be managed appropriately. From the Norwegian infrastructure project, Steinar and Katrin, we heard amazing numbers, 5 months to 5 hours. Models
5 weeks.
Ranking.
Sorry, 5 weeks. Sorry, Steinar is just correcting us.
Oh,
yes.
5 weeks.
Well,
Okay.
in Norway, it's 5 weeks. In other parts of the world, it may be 5 months. Yeah. So.
Okay, updated in the notes. Thank you. Models rank above drawings contractually, and open API being important. And also from Katie at Alice, we heard shared source of truth is a critical piece, which is often missing. And we also heard, especially important for this group gathered today, owners have a critical role to play in innovation, and that role is in demanding, expecting, and supporting the innovation. So thanks to everyone who's done these wonderful presentations today. We also have a couple of open questions from the audience, but we're sure that there are questions in the room as well. So maybe, Calvin, if you can help us bounce back and forth.
Yes. Let's do. Why don't we start with those online, Tony? What were some open questions from those online? And maybe we'll also invite all the panelists so far to feel free to turn on your camera.
Okay. One question from Brian Colley was in regard to Finland model and bridge structure. Do you associate shop drawings, steel type, concrete properties, sampling and testing, inspection, attributes with these elements?
Yeah, well, yeah, this is Jiri. So the bridges are designed using these models. So what you saw is the design model that's been converted to IFC. So these have all the properties, all the information needed for constructing the bridge. And then once the model I showed you is submitted to the bridge maintenance system, then that is the place where all this sampling, testing, maintenance, management data is associated then with that model. So it's because it's the model that's used for actually constructing the bridge, then it has all these steel types and concrete properties in it.
Mm-hmm. Thank you. Thank you. How about locally here at Stanford? Any questions? Please, if you don't mind, come on out so that the global audience can see you. Thank you. Please introduce yourself. Great.
Okay, thank you.
Thank you. From here, if you don't mind. Yeah, just thank you. Thank you, Brian.
All right,
yes.
Thank you. Yes, I'm Brian Terry. So on the owner side, I work for Genentech. I heard a lot today about collaboration with government, right? And also this concept of using your model as a single source of truth. And I'm wondering how we've seen the efforts kind of evolve over time to kind of what we've seen from a governmental side for accepting a model instead of a drawing. I think right now a lot of our challenges for permitting, we require drawings. So we're using the model to produce drawings. I'm wondering if there's a collaboration there. Yeah.
Mm-hmm. Thank you, Brian.
Thank you.
Thank you, Brian. So that would be a good topic for many of us, both in the vertical side and the infrastructure side. Maybe first let's learn from our global colleagues. I wonder if any of our global panelists from Norway, from Finland, from Estonia, Netherlands, in UK, any lessons in terms of how they are accepting BIM as a legal document, as an approving for permit approvals and the like. I see that Steinar will be coming up. While Steinar is coming up, maybe Rick or Katrin or Jiri, anything to share? Sorry. Oh, Katrin may have to leave. I know it's getting late for Europeans, but please, Steinar, yeah. Please. Oh, yes, Jiri, if you want, please go ahead first, and then Steinar.
Yeah, well, in Finland, we are starting to accept the models for the building permit. I think that's a global trend to accept them. But what was even new for me was the Norway, that they put the models in the ranking order above the drawings. So that needs to happen. But I haven't seen much of that happening yet.
Yeah, for Norway, this was called a game changer. So the owners, they saw that they needed to do a change in how they actually execute the project. And when you have both at the same level, both drawing or model, or you have drawing over model, it will never work as far as my experience. You need to have a model as the one common truth of the project. One of the things we have problems with in Norway today is third parties. municipalities other that need to have some sort of drawings to actually approve, but they are all generated from the model. So when we get questions about third parties that really need a drawing for their approval, we will generate that drawing from the model, not separate drawings. So it's been a change, and it started back in when the government started to see that we're actually losing money on the way we are doing contract, because general contractors would then ask for more money because it was indiscrepancy between the different drawings. And you have a lot of indiscrepancies between the drawings that you don't get in the model. So, yeah.
Thank you, Steinar. And then we also have Ian.
So maybe a couple of observations. And for our international audience, I'm going to use the term AASHTO, which is a coordinating body for all of the state Department of Transports here in the US. Their construction committee did an interesting exercise with contractors, and they took what they considered a standard set of civil engineering drawings and asked the contractor to mark them up in 3 ways. Green, we really need this information on a drawing. Red, we don't need this information at all. And yellow, you can get that information to us in better ways, for example, through a specification. And interestingly, only 1/3 of what was on a typical drawing set was marked in green. So there's a lot of duplication, redundancy, and information that is noise that doesn't help the process of getting road design to construction handoff. So that construction committee research was shared with the Joint Technical Committee on Electronic Engineering Standards, who are really promoting the use of BIM and starting to use modeling in the infrastructure space. Now, you could argue that's 15 or more years behind the building industry. But the basic question they've asked, which is fascinating as later adopters of BIM, is why are we creating the model to actually produce the drawings? Brian, your exact question. Right. And they're saying, that's stupid. Why can't we just use the model? So AASHTO is really advising the state DOTs to adopt a strategy called MALD, Model as Legal Document, where the handover is from the design team to the contractor as a full digital model, and not doing drawings other than where maybe needed for a specific standard detail or so forth. So that is a new initiative, and in a way that's sort of leapfrogging the building industry's long time adoption of BIM, because they're literally rethinking about that and doing it in a different way, particularly based on the survey with the contractors in terms of what was the critical information. So AASHTO are now starting to reach out to American general contractors and ARTBA, which are many of the heavy engineering contractors, to say, guys, we're going to start giving you model data, not drawing data. You need to educate yourselves on how to take that and use that as the source of truth for the dimensional information where it's going to be read directly from the model. So that's a really big shift. It's obviously very much in early stages. It does raise questions of level of detail in the model, the maturity of the model, and those are all being addressed through the AASHTO committees. So that's kind of an up-to-date on status, where I think the horizontal infrastructure space is going to leapfrog, just like, you know, all those countries who didn't have cable and suddenly went wireless instantly. It's kind of that kind of tectonic shift where the guys who were the laggards are going to become the leaders. So
thank you, Ian. We have Jim, and then I'm going to follow with a final questions for the panelists. Thank you, Ian.
So
introduce yourself.
Oh, Jim Bedrick. I'm with Strategic Building Innovation. And I'm also I was with the AIA Documents Committee for 13 years, and also I lead the development of the BIM form LOD spec. Ian's exactly right. There's this leapfrog effect. I think the horizontal industry kind of did the classic fast follow on BIM adoption, because what seemed to happen was, for a long time, the vertical sector was ahead, and then all of a sudden it seems like the horizontal sector is ahead of the vertical sector, and especially on this idea of the model as a legal document. In the AIA Documents Committee, I worked on all 3 iterations of the BIM documents, first starting in 2008. Just recently, last summer, we put out the 3rd version. And that the E201 specifically supports the idea of a model as a contract. What was really interesting is that we started talking about that probably 4 years ago. And the committee is about 50 people. About half of them would say, yeah, okay, that might be a good idea. But the other half were just heels dug in. No, not ever, not no, but hell no. One of the people who was most opposed to the idea of a contract of a model as a contract became the leader of the group that developed the exhibit that specifically allows for and supports the idea of model as a legal document. So it is something that it really scared a lot of people at first, but is becoming mainstream now, even in the vertical industry, which again, as Ian pointed out, we're now following the horizontal industry, and hopefully we'll catch up soon.
Thank you all. Also, additionally, I think here in the US, different federal agencies have tried to work with BIM and process that, like what my team has done with GSA 20 years ago, trying to accept BIM and try to compare that. And then, of course, the AISC did try to also say that if there may be kind of like a little bit like the Norwegian example, if there may be discrepancy between BIM and 2D, would BIM actually take precedence? I think that was also in place some 20 years ago. But actually, I just flew back from Singapore Tuesday night, and Singapore Building Construction Authority have been to this building 10 times over the last 10 years, and working also quite closely with us over the years. They are going to go from CoreNet, which is an electronic submission hub that started to require BIM as a submission 10 years ago, to what they now call CoreNet X, which is 100% based on IFC, and it's also an IFC BIM-based evaluation. So whether it may be the Land Transportation Authority or the buildings or the fire code, everything will be coming to Singapore in an IFC form. And then for this city, state, country of about 5.5 million as a jurisdiction, they will be requiring openBIM for collaborative support, for model-based evaluation, and that work is ongoing. They're calling that kind of like the IFC SG version of the IFC, with very detailed also specifications of the requirements mapping to traditional way of bridges, roads, buildings approval. So I noticed that we are getting towards the end of session 1. If I could just ask any of the panelists who, it's not too late in Europe, do you have any advice or tips? For example, Jiri or Steinar or other Katie, any recommendations in the theme of seeing it's believing? What can we as a community? We have Caltrans, Genentech, Stanford Healthcare as an asset owner here in person. We have Boeing, we have Lucid Motors, we have 19 other states DOT signing up online and Federal Highway. What may be your recommendations to our community? What can we all do by the end of the year? So maybe starting from Finland, Jiri?
Yep. Okay. Yeah, my recommendation is not to worry so much about IFC, the technical stuff, all that, new versions, old versions, and so on, but to think about what is the data you need for performing, enabling your operations. And then the secondary question is, how do I capture that data that I really need in the IFC model?
Thank you. Thank you. Really think about kind of like have the end in mind and have the business needs. Thank you, Jiri, and for joining us pretty late from Finland. And then Steinar and Katie.
One of the learnings, I think, or the main learning from Norway is actually demanding it in the contract. Nye Veier demands a lot of development. They came with a lot of high demands. They had put the bar quite high for us. And then we started to have a negotiation and discussion on what we actually can deliver. and what is the best approach. And that pushed also the general contractor and also the consultants and actually raising the bar. So to put demands maybe a bit higher than usual, and then have a discussion with what is actually feasible for the contractor and having that discussion, because if you don't raise the bar, how can you actually move on? And I think it has to be the owners that actually sets the bar at the level they are expecting. And I'm not talking about saying that we want IFC, but we want a new way of working. What do you demand from the general contractors and the consultants?
Thank you, Steinar. And then Katie?
Yeah, I'll just add, as humans, we learn by doing. We don't learn by sitting and studying every angle, guessing what might go wrong. Like, we just have to get in and do it. I really liked what Jiri said. Don't worry, you can just start today. And I think that's really true. And the other side of it is that you don't have to start with something super high stakes, and you don't have to boil the ocean. For any time that you're adopting new technology, start somewhere, gain some traction. By going through that experience, that's where you'll actually learn how close you are to being able to roll it out fully, and what you might need to learn or change to get the rest of the way there. So we learn by doing.
All right. With that, let's give a round of applause for all our panelists. And we'll take a short break, and we'll continue in about 10 minutes time. So thank you all. For those in person, we've got coffee and tea, and we've got a very nice terrace just over there. So make good use of that. Men's room, women's room are just down the corridor. So we'll resume in a few minutes, and we'll continue our tour of Europe by going to Italy in 15 minutes time. So thank you. Oh, and by the way, for those in person, we've got free upgrade for many of you. There's some amazing first-class seats. So please come on over. Yes. Yes. All right, we should be resuming. Again, we've got some amazing first-class seats for anybody who would like to upgrade as we take our journey from Stanford back to Italy. So good evening, Michelangelo.
Hello, hi everyone.
Hello, can we say, how do we say hello in Italian?
Ciao.
All right, ciao. All right, so Michelangelo, thank you for joining us also in your case pretty late in Italian time to share with us live in person what ACCA has been doing with lots of open BIM innovation, especially focusing on both infrastructure and the vertical side. So the floor is yours, Michelangelo.
Thank you very much, and thanks to you for the invitation. I would like to talk to you about ACCA latest innovation in technology, which is about transforming open BIM to GIS digital twin. For those of you who do not know ACCA, we have a really clear mission, which is to transform BIM into open BIM. And in particular, what I would like to present to you today is ASBIM GeoTwin, which is our latest evolution on how to develop a GIS digital twin. Technically speaking, it is a connection between the ArcGIS platform from Esri and the ASBIM platform from ACCA. I will show you different examples and different use cases. In particular, we will use always open BIM formats, in particular with IFC models, up to the version 4.4. We will see briefly also a tunnel model, which is the latest development from Building Smart. We will focus for such examples both on buildings and infrastructures, but in general, all the use cases that can be done on the buildings can be done on the infrastructures, and the opposite is true as well. We will see, for example, application of asset management, asset operations, facility management, Internet of Things, and so on. I will just start with the video and explain to you the technology along the way. So we will start by having a look at ASBIM, which is our cloud system. So everything that we will see here, both from the BIM and the GIS part, is done in the cloud. And actually, we are looking at an openBIM model, an IFC model of a building. Actually, it is not a single model, but it is a federation of different models, the architectural, the structural, and the MEP part. Of course, each object, each IFC object carries its own properties. But now let's move to the GIS view that has been done in collaboration with Esri. Here we can see a federation of 16 IFC models. These are the same that we were looking before, but actually deployed on the GIS view. Actually, and this is very important, the connection that has been made between the BIM environment, the BIM platform, and the GIS view is dynamic, which means that all the data that is about BIM is stored on the BIM platform. And there is no exchange of static data. All is dynamic. So if I select the objects, the system queries the BIM, the GIS system queries the BIM platform to access the information in real time. And we will see why this is important and fundamental for such kind of integrations. We can have all the functionalities that we have seen before on the BIM platform, also from the GIS view. And of course, all the functionalities such as the GIS layers as well. And I was talking about this dynamic connection, and we will see later on why this is fundamental for this technology. Here, another important thing to notice. These are 160 buildings in IFC models, which are very heavy in size, which shows that the technology is powerful with regards of scalability. So because the system is dynamic, the data that is exchanged is exactly the one that you need when you need it. And this allows to have unlimited scalability. And what we have seen in practice is that this is very important because other systems that may exchange data in a static way have limits with regards of this possibility to scale up in terms of extension and about the dimension of the models that have been shown. Here we are back to the BIM view, to the BIM platform. And what I was talking about before was about this dynamic connection, which means that the BIM users can actually continue to do their update of the model. Here, for example, a simple operation of adding a new model to the federation means that we will have a new building in the BIM platform, and this information is automatically updated in the GIS view. So this dynamic updating means that everything that happens on the BIM side from the BIM users is actually seen in real time from the GIS users. And if you think about how other functionalities of the GIS works, like for example, viewing of the layer, you can combine the viewing of both GIS and BIM data. Now let's move on this shopping mall and let's see another application, which is the connection with the facility management system. So actually, we are in the GIS view. We are querying the openBIM data from the BIM system, but we are actually connected with the facility system, facility management system. So for example, each object that we can locate from the facility management system has all of its properties and tickets and maintenance history and so on. And this is very powerful because each system is doing its own part of the work. There is no static data that is flowing between those systems. But thanks to the use of open APIs, the data is dynamically exchanged. And this allows to have always the data that is up to date. Of course, there are also other kind of functionalities, such as the use of virtual reality and augmented reality, which are useful in case you have to, for example, inspection the site before maintenance or other kind of operations. So from the territorial level, we now move on to another part of the map where we can see a railway station. This is the Naples railway station, and it is actually a federation of more than 50 IFC models. Here again, the powerful thing is that you can do geospatial queries. The GIS system can do geospatial queries by getting the information from the BIM models. And so here we can inspect the details of the station. Here we are querying an object again on the BIM, querying the BIM system to see what are the attachments to the particular object. In this case are photos, but can be documents and other things as well. Now we move more on the infrastructure part. This bridge seems kind of simple in its geometric form, but it is actually a really good experiment, because on this bridge there have been placed IoT sensors that returns in real time information about inclinometers, accelerometers, and so on. So again, we are connecting from the GIS view, querying the openBIM model in order to connect it to the IoT system. And with the IoT data, you can do all the kind of analysis that you can think about. And it is not only about this single bridge that you are looking at in the map, because if you have all the bridges of this territory, then the GIS systems can do queries that span over all the bridges from which you take information from the system of the BIM. Here we have seen the road, an example of the road, and here, as I said, an example of a tunnel, which is in IFC 4.4 version, which is actually at the development of Building Smart. Here we are back at the bridge, another bridge. This time is much more detailed from a geometric point of view. And again, you can use virtual reality in order to navigate and explore it directly from the GIS view. But IFC can represent really anything. So here, for example, we have a power plant IFC model, which has completely different objects and properties. But the good thing is that all the models are in IFC, which means they are structured all in the same way. So this means that the query geospatial queries from the GIS system can work among different kinds of infrastructure and buildings. Of course, it's not always about IFC models. Sometimes you may have only cloud points. Here we are looking at a football stadium with a point cloud of 50 gigabytes. So there are something like 2.4 billion points. And sometimes you have both. You have the cloud points and the IFC model. This is a railway of 50 kilometers in IFC 4.3. And actually, the IFC model has been created starting from the cloud point. But in the GIS view, you can see them combined. So you have both the cloud points and the actual IFC model. I just want to focus a little bit on this dynamic updating of IFC models in openBIM from the GIS view, which is something that I have introduced in the beginning when I talked about this dynamic connection. Because at ACCA, we really believe, we really think that during the operation and the maintenance phases, maybe 10 years from now, you will not have any more access to the BIM authoring that produced the openBIM model in the first place. So we really think that the IFC model should be made dynamic, and we offer functionalities that allow BIM users to do modification directly on the IFC openBIM models. We will see an example where we will move an object from the perspective of a BIM user, and we will see what this means from the GIS user point of view. So if we start moving around the object, the change is immediately reflected on the GIS system. But now, it may seem very simple to move around objects, but if you think at more complex operations on the geometry, but also on the data that such objects carry around, you can think about how powerful it is, because the queries from the GIS system are always up to date with the updates from the BIM system. So all the functionalities that we have seen so far and much more are part of this digital twin technology. And really, there are no limits in what you can build on top of this. And to conclude, I want again to point out that all of this has been done with a dynamic connection between the GIS world of Esri and the BIM world of ACCA. So the user from the BIM perspective continue to do what they have always done, as well as the GIS user continue to do what they have always been done. And this integration allows to have all of the benefits that we have seen so far and much more. And of course, always using openBIM formats. So with this, let me introduce myself. At last, I am Michelangelo Cianciulli, and I am openBIM and IFC expert at ACCA Software. I leave you with my references, and I thank you very much for your attention.
So thank you, Michelangelo. For some of us like Ian, myself, and representatives from ASHTO and some US representation, we were able to see some of those firsthand during a BSI Building Smart International Summit just a couple of weeks ago. And what Ian and we are trying to do is to filter some of the highlights and introduce it here to our friends in California and also the community here. So thank you so much, Michelangelo, for staying behind late in your day to join us.
Thank you.
So in the next part, let me get the screen share as well. All right, okay. All right, thank you. So for the next part, my team at SBI, Strategic Building Innovation, also want to show some projects we have done globally. And again, the theme is that how we can not wait for perfection to be in place, not wait for all the funding, all the prerequisites to be in place, but what we can do with even emerging standards, with standards being in development, and how we can bring the data-centric approach, how we can bring value-minded approach to bring value, especially to asset owners and operators. And so IFC industry foundation classes has been a staple with Building Smart for over 2 decades. Yet open standard with Building Smart, it's more than just IFC. So in this series of presentation, we also want to show, for example, an emerging standard of what is called the IDS, Information Delivery Specification, can help owners, operators to better define the requirements in an open standard manner that is machine readable and exchangeable. And what we can do with things like IDS in a matter of months during COVID. All right, so first of all, teaming up with a lot of our global partners, we were able to come up with a proof of concept in a matter of months. What that was about is to bring over 149 infrastructure, building, open standard models in IFCs and put that in an open standard environment. That we are using openBIM, we are using openGIS, such as CCM, CityGML, IFC, IDS, and the like. Putting them together is one thing. Sure, it gives asset owners an additional flexibility to manipulate the view, be able to apply different plugins and solutions, very similar to what we have seen in the morning from Norway, from Netherlands, from Finland, and the like. Yet, it also gives asset owners an additional opportunity to ensure that it's not only pretty movies, pretty pictures, pretty BIM. What about the data behind it? Can we quality assure, quality control the data? Similar to what we have done here at Stanford with Finland government 20 years ago, applying the first IFC, or with the US GSA, Public Building Service, some 15, 18 years ago, to focus on what we can do with quality assurance. So even though the IDS was a new standard 2 years ago, but our team did not wait until it got kind of like go through full version 1. We went ahead and team up with Building Smart International and see how we can bring that in an actual setting for an international government agency and be able to apply that. And that was all done during COVID a year ago, when a couple team members actually were slowed down by the pandemic, yet we did not need to wait long. Within 4 months, we were able to not only apply 149 open BIMs, come up with over 20 checks, evaluations, put that on a cloud platform that is scalable, ready to and poised for a city scale. So to learn more about that, let me also introduce another Stanford connection we have. Dr. Min Song and I are also all part of the SciFi community. He also got his PhD from Stanford just a couple of years ago, and is now one of our colleagues, along with Janice, Tony, myself. We are all also proud supporters and volunteer leaders for Building Smart USA. So joining us from Vancouver today, Dr. Min Song.
Thank you, Calvin. Next slide, please. Okay, so then this is about IDS Checker. IDS Checker is a type of model checker, but it's based on openBIM. So why did we, decide to use openBIM-based checker? There are, other checkers that are based on proprietary formats, but we didn't use those. We used openBIM IFC-based checkers. Primarily based on our experience and the data that you're seeing, the metrics that you're seeing here is based on the collection of records from our previous projects. So if you compare the hours for developing manuals on the left side for model checking, and then at the center developing some rules, model checking rules, the hours for that, and on the right side, locating these 3D objects was issues after you're running the model checkers. If you compare those hours with non-openBIM approaches, openBIM can save around roughly on an average 70 to 90% of the time. And I won't go into the details and where the numbers came from or the projects this numbers came from, but that's one of the main primary reasons why we pushed for openBIM-based checker. Next, please. And then on this project, the IDS Checker project, when we were coming up with the IFC requirements, information requirements for the platform, we focused on the requirements that will help integrating BIM and GIS on a city scale and a city level. So it was not really about what you're seeing on the right side. It was not about a single project. It was not about code checking. It was more about project level data or the metadata on a city scale, having a CDE that has thousands of IFC models in the future. For those type of use cases, what are the information items or properties or entities that needs to be checked? So that was the main focus of the IDS on this project. Yep, next slide, please. And some examples here. So there were about 10 IFC requirements written in IDS format. That's an XML format. And one was about georeferencing. And then this was really important for integrating openBIM and openGIS, because when you upload your IFC model to a CDE that integrates BIM and GIS, you don't want to manually place your model onto a 3D terrain. It has to be automatically located at a certain place, accurate location on a 3D terrain. So this georeferencing information in an IFC model was very important, but then there were so many different ways of georeferencing in IFC, as you can see here. So we had to question which method to follow, what IFC version to use. And for this project, we use IFC 2x3 version, and then also IFC 4 version. Next, please. And another requirement example here, this was about the properties or the P sets. So in this case, if you have an IFC model, the model should have high-level information like project name, project owner, project number. So you can, for instance, if you want to do a query, all the projects owned by a certain entity could be a return of using this type of a property information applied to different IFC models consistently. And these are just a couple of examples, but there are more property or PSS information with LOD metrics that we had to consider. And then on this video, this is the interface of the IDS checker, basically converting those IFC requirements, some of the examples that you just saw, into a model checker. So if you upload an IFC model to this platform, the IDS checker will run and check whether the IFC model is following the information requirements that you saw, a couple of those before. So those checks on the right side that you're seeing here are pretty much high-level, information checks like the project name that I've mentioned and whether the model is simplified enough or not. Because when you have thousands of models uploaded to the platform has to be, very quick and fast. So it cannot really handle detailed objects. So whether the model is simplified to be handled on the CD, that was one of the requirements as well. Next slide, please. And these were some of the IDS metrics we were able to get. Like I said, we had a lot of IFC models on here, and we tested 102 infrastructure models, IFC models. In addition to this, we did have 47 building vertical project IFC models, but we did have a lot of IFC models here. And after testing or checking some of the models that we got, the average score, overall average score of the IFC infrastructure models was pretty low. So out of 100, it was around 50. And one of the reasons was that mainly the models or the authoring tools that were used to model these BIM were not really supporting IFC 4.3. So a lot of objects had to be exported in a proxy format. So that's one of the reasons why the IDS scores were low. But another way to overcome this type of problem issue is like using normalization method that Jiri mentioned, which allows you to fix your IFC model if there is something wrong. So that hasn't been tested on this project, but that's something that we are looking forward to implement in the future. Next, please. So just to wrap up this IDS project, so these were some of the openBIM metrics from this project. On this project, we integrated openBIM and openGIS, and this is also in partnership with the Future Insight, the first presentation that you saw today, and also a solution and a company called BIM.works and BIM-base. And with those partners, we used 8 open standards, and we developed a 10 IDS specification into XML. Also developed the IDS checker that reads the 10 IDS specification, and tested 102 infrastructure models on that platform. And for checking individual model, the average time it took for us to check individual model was roughly 12 seconds. So that was pretty quick, yeah. Next, please. And lastly, these are some of the use cases that were done with IFC-based CDE, integrating openBIM and openGIS. A lot of we think that IFC is used for archiving purposes, but like, Future Insight mentioned, Rick mentioned in his first presentation, IFC can be used with IFC-based APIs, and using those APIs, you can enable different use cases that integrates openBIM and openGIS, and also, implements IFC-based infrastructure models into these use cases. So with that, I'll pass it on to you, Kelvin, for the next part.
Thank you, Min. So what our team at SBI has been focusing on is how to assure information to go along with the pretty picture and the pretty model. And so reflecting back 20-some years ago, when I was a graduate student here at SciFi working with the Finland government, we were focusing on how to do model checking on one historic project using, among in the world, one of the first IFC 1.5 at that time. Sliding the scale a little bit, 18 years or 20 years ago now, with the GSA, Public Building Service, we are using IFC to look at how we could automate at that time the evaluation of a federal courthouse in a matter of 1 minute, tens of thousands of routines and evaluation. And then 2006 or so, working with multiple vendors, Autodesk, Bentley, Graphisoft, the list goes on, to actually all be united at the National Academy of Sciences in Washington, DC, to actually have a little show, seeing it's believing, that each of the vendor demonstrate how to use the GSA BIM guide, apply that, and be able to allow the GSA, working with Finland, working with global partners, to be able to automate quality evaluation, circulation, security, among other things. The difference of the last 20 years of what you just saw was that we are now able to get away from a desktop application on one project to a cloud-based application where we work on a city scale. We are also able to get away from just building by going into building, GIS, infrastructure, building can all be done still in a matter of seconds, 12 seconds per evaluation. Some of the evaluation that Min and I were showing, we could then automate tens of thousands of manual routine to check if certain IFC compliances were met, certain fair use were being done right. Very often just by eyeball or just by some manual process, it may be more difficult to do that. So can we bring some of those global examples or historic examples to 2023? And what can we do together? So to continue with like the global tour, let's also go to Asia a little bit. Earlier, I talked about what we have seen from Singapore. Our team, in this case, also work on vertical side. In fact, one of the 10 tallest buildings in the world, 3 million square feet, that's thousands and thousands of assets. We went from no BIM to not only BIMing it up, but highly using openBIM. And we are able to actually load it up on a phone, on a laptop, inside the mechanical floor, and be able to stream those openBIM so that it can support IoT integration, Internet of Things, to support asset management, preventive maintenance. It's digital twin, it's the commercial side, it's the data interoperability, all workouts? No, definitely not. But does it slow us down from working with the asset owners and finding fair use beyond what they were doing with paper and Excel-based operations? Absolutely, yes. So in that journey, we were more focusing on, like many speakers were presenting, what were the business case of the asset owners in this case? Each of you may have something very different. What you may care at Genentech could be very different from Caltrans, certainly very different from this skyscraper operator. But in the end, it's still about asset. It's still about scenario planning. It's still about evaluation. So for example, to Terry, who talked about whether we could do some permit check and agency review, we are nowhere close in terms of policies, in terms of politics, in terms of mindset. But then the technology has been there. 20 years ago, we brought similar technology from Finland to Finland, similar technology from Finland to Washington, DC, and in this case, to other parts of Asia, that we are able to use readily available technology, 100% using openBIM, to turn something that usually would take 21 days, even today, with good expertise and good kind of like professionalism, down to 1.5 days if you have to remodel something. Then if you have the BIM available, we could do the evaluation in a matter of seconds. So the question connecting to our next 20 minutes of Q&A and discussion here is that, what kind of quality platform do asset owners in the room or in the virtual room would like to see? How can we let openBIM, open standards, to help us cross this bridge? And then for many of us in the room, we have a couple of handouts, which is also about the theme of this seeing it's believing, is that what can we do between now and the end of the year? Just artificially taking a stake in the ground. Let's try to get something this year as a community. Many of you may be solution seekers as Caltrans, as Genentech, as Stanford Healthcare, as many other owners. I think we have almost 20 state department of states, DOTs in the room, State Department, NIPS in the call. What would you like to see? How do you want to prioritize it? And then for solution facilitators, we have many experts in the room, or solution providers. Some of them have presented, some of them will be presenting this afternoon. Many of them are highly connected with the BSI community. What can we do together? Can we make something that is accessible? Can we make something that is more standardized, more normalized? Can we turn it into an open BIM-based platform for the US community to grow together? And yes, it may involve different kinds of solution set, things on the cloud, things securely being protected, open standard. We will work out the detail. But then those are some questions we want to bring up. Can we improve the quality of the BIM that we are receiving? Can we start to come up with a building smart data dictionary that can speak the American infrastructure language, that can speak the American pharmaceutical business language, and what can that open us? Again, it's not something we have not done before with GSA, with SBI, with SciFi. We've done it over the last 20 years. So at that time, almost 20 years ago, we started. We presented that back in 2006. We were able to demonstrate how to bring in the same GSA model from different sources, different vendors, coming through open standard, able to automate things on the right-hand side and demonstrate value. So the theme for some of you who may be new to BSI is that I wonder if Ian, you may want to kind of like help us appreciate where openBIM or where the community is going. We've got this one slider, which I believe is the latest and the greatest strategic roadmap.
So we actually have a brand new international CEO, quite Julia, that's joined Building Smart from a Bechtel background, project management delivery background, really complex, as you can imagine. We worked on nuclear submarine programs, etc. So someone of the mindset of, how can we make a difference globally for the industry and stop having projects that run over time, over budget, the story we all live with as status quo. Certainly one of the themes is looking for return on investment, looking for the value. In other words, if you have to do maybe a little more to create open BIM data upfront and to actually assign property sets to objects that give you the data that you can then analyze, what's the return on investment? And one of the things that the Building Smart community are looking for there, as you can see, is sustainability. Every organization has sustainability goals. And how can you map some of the open BIM work to achieving those sustainability objectives? So it's not just about efficiency. It's not just about digitizing the processes we've used before. It is just as Ashko doing, questioning the status quo. Is a BIM model, is the object of creating a BIM model to produce a set of documents? And increasingly we're seeing that isn't a value proposition. That isn't an ROI. Can we use the model as legal document? So I think one of the important things that we've seen throughout the presentations is that Building Smart International, the first point of contact a lot of people have is this data schema, this industry foundation classes, but you've seen reference here to the information delivery specification. What we're asking owners to do is to write down your information requirements. What is it that you're going to need at each phase of a project to hand over from design to construction, to actually get as-built information for asset management, for making good decisions for operations and maintenance. If owners are clear on their requirements, and to Steiner's point, are willing to put that demand out there in terms of this is the information we need, those exchange requirements can actually be met by a lot of the open BIM tools that are in place. So this innovation for information delivery specification, Calvin, you started working on it in terms of early validation, but right now it is going through a voting process by the entire Building Smart community to be adopted as a new standard, which indeed will be used by everyone to make a clear specification of information requirements. Why are we using IDS? Because it's machine readable, which means we are now building a validation service that says, if this are my information requirements, and this is the IFC file I've just been given by my architect or my engineer, run it through the validation service to confirm that 100% of the information is actually there per your information exchange requirements as captured in the information delivery specification. So trying to put a lot of rigor and robustness and tools in the hands of users that can really bring these things to reality, because you've seen a lot of work today by pioneers where it does take quite a lot of technical ability to make it work. We're trying to take that mystery out of it and say, okay, in the hands of a normal user who's creating a model, can they add property sets? Can they extend those properties into the data dictionary? Can they, in fact, run the validation service and prove that their file is complete? All in the hands of users. So I think that's, to your point, Calvin, kind of a big part of the new work, because IFC 4.3 is being defined. It's running through the ISO voting process right now. We're expecting to come out by the end of the month as a new ISO standard. It's now, how do we deploy that? And how do we focus on educating professionals through the training and certification programs? And really, we're in what I would call a deployment.
Thank you, Ian. So what we want to do is that my colleague Min will be setting up a Mentimeter to engage us. Basically, we would like this group to start thinking about, and we continue after lunch, is that would we like to contribute together, teaming up with Building Smart USA and one another? There are different things we can do. We can, especially as asset owners, let us know your pain points, prioritize the data or the data strategy or the value proposition of why we are going digital. And then, or you may contribute, and I think in a discussion with David Unkefer from Federal Highway, that maybe different states may be able to contribute some BIM, some open BIM, so that we can work on it as a sandbox, as a community. Would you be able to offer some BIMs, be they open BIMs or native BIMs or whatnot, so that we can work on that? Are you interested in being engaged in this pilot, so that we hope that the discussion does not end at 4:15 today, or maybe 5:30? We've got some beverage and a terrace outside of us, but how can we continue that beyond today? So with that, I would like to turn it over to Min. I think we have some Mentimeter questions that we want to engage, not only those of us in the room, but also those of us virtually.
Okay, just share the screen. Do you see the screen?
Yes. So for those of you who may be new to Mentimeter, with your devices or any internet browser, you can click on, you can type menti.com, and then that's a code. You key in 7973933, and then we can all contribute.
Right. I was looking for QR code. There is a pop-up window here, but I'm not able to find it. But yeah, like Calvin said, you can just go to menti.com and plug in that number. You should be able to see this survey. So, in the morning we have seen the use case examples. So now that you have the better understanding of the use cases, what would be the use case that you are interested in seeing? So most of you probably have used this tool, but you can just select 3 options here or choices. And then so results are coming in.
And then as
And
we're doing that, yes, Min, please continue.
And you might not see a use case that you are interested in here. So the next question is an open-ended questions for that. So after this one, we will move on to the next question, asking a use case that might not be listed here.
Good. Anybody want to voice over that? We welcome all the diligent team, but anybody want to voice over? Maybe from Caltrans, what have we learned today, or any particular use cases that you may be interested in?
Rush, you want to go first?
Yeah, I think the model delivery is a legal document. I think to me that's one of the key aspects to the proper legislation. Contract, which started adopting that. So to me, that's probably one of the key aspects of the horizontal infrastructure.
Yeah.
Successful. So,
yeah. Again, the sound bites from Norway was that they not only trust the model, but if anything kind of like being discrepant, it would rank or take precedence over other documentation, right? So certainly something for us in California, or even us in the States, that we can learn and build upon. Thank you. Yes, please.
Yeah, this question is basically the same question.
Min, we will have Sarah. Please, Sarah.
Okay.
Yes.
Okay, sorry.
Responsible infrastructure, we don't need existing conditions to also be converted into 3D models, and then also having it in the entire IFC, so just a conversion. I feel like the existing condition is available governance like that.
Yeah. How do we capture existing condition and the array of tool set, right? From airborne, LiDAR to penetration subsurface, exactly. Yeah. So all those are very good. Yeah. I actually also saw something very interesting from Singapore just earlier this week, so we can compare notes on that. Thank you, Sarah. Yes, Min, let's continue with our other question set.
Yes, this is basically the same question, but in case the use cases are not listed on a previous question, this was an open-ended question, and we see a lot of MALD, some other use cases like scheduling based on openBIM. I think Alice can be categorized as that use case also. Road maintenance, bridge inspection. And then we did have a similar survey before, so some of you might have participated in a pre-workshop survey. It was very similar to this one, and I think there's a slide in the opening session deck, but if you see that during the pre-workshop survey, I think one of the use cases that were ranked high were pretty consistent with what we're seeing here. So I don't have exact numbers, but I remember the model checking was high, data query, integrating BIM and GIS, and then doing the query based on that was high. And then the schedule, the predictive maintenance platform, that was also, voted high in that survey.
Very good.
Here, yeah.
All right. Maybe final sets of 90-meter questions. Yeah.
Okay, so we do have two sets. One is asking about business value, but the other one, the later one, is more important, asking about call for participation. Do we have time to go over both of them?
I think we have time to do both. Yeah. So because I think it's equally important to understand your perspective, buildings, infrastructure, city level, where you see as the business value drivers.
Yeah. So how do you see the business value of openBIM? It's an open-ended question. Some people say, openBIM cannot really do everything, which probably is true. If so, what are the top maybe 3 or 5 areas where openBIM can really help you save money and resources?
Anybody want to voice over any business values? Risk reduction, single source of truth rather than multiple sources for confusion. Carbon reduction, certainly also a major focus of Stanford. As part of civil engineering department, we are now part of also the new school of sustainability. So certainly something we care a lot as well. Fewer change orders. All right, maybe let's go to last but not the least, an important question to ask. How can we move forward together? How we can frame it up for our afternoon discussion?
This program, Seeing is Believing program, how you can participate is after today, we can look for asset owners who need help in testing openBIM and testing solutions. Listen to areas they are interested in solving, the areas where solution seekers are interested in solving, whether those are certain use cases or not. Find existing solutions or solution providers that fits for that use case that the solution seeker is interested in. So that's the approach or the next step that we want to take. So this question is mainly for solution seekers, but also open to other people as well. Here, we are asking if you are interested in pilot tests. This would be the best way to engage in the program, but there are also other ways to contribute. You can simply, stay in the loop and get updates about the program, and we will occasionally update you with emails and next workshops if that's scheduled.
Thank you. So do we have any virtual remote participants who may want to share any questions, any thoughts about these questions? Do you want to voice over some of your thoughts? Or if you may want to choose something that is none of the above, feel free to voice over. So do we have any questions or comments? Anybody raising their hands? How about locally? We've heard from Caltrans. We also have Generative and among other asset owners in the room. I noticed that remotely we also have Lucid Motors, Boeing, other state DOTs. Any thoughts? And of course, Caltrans also, other teammates from Caltrans. Where do you see in terms of something we all can team up together with building smart community? Yes, Yi, please introduce yourself.
You want me to come up? Or?
Yes, please come up. The camera is still on, so you can just turn on the camera too. Yes, please join us, Eve. There we go.
Pleasure, Eve Edelstein, and I'm an outlier in the group. I'm a neuroscientist, former clinician, and architect. Yeah. And so I deal with that messy problem called humans. And, and what I would love to see, being both a scientist and having worked in the field and on real built projects, is that BIM data starts to include some of the actual measurable data that we have about the human impact of design. And whereas we can suggest it's all too messy, it's complicated, we don't have the information yet. What I've heard in this group, which I just loved hearing, is we don't have to wait to know everything. We actually know enough to start to include some really important features that can design from pre-design all the way through building materials, construction, and post-occupancy. So I'm a member of the Academy of Neuroscience for Architecture. So we've been going 20 years now. I think that means we're at the tipping point. And so as our buildings start to think about how do we design and build for things like neurodiversity, how do we respect that part of sustainability is sustaining human health and well-being so that we're actually more productive? And how does all of that factor into a return on investment in design? That's where we have data. And I would love to see that as part of what we bring in with the information we want in BIM, because we can specify how much light is coming in through this room, this building, and what the human circadian rhythm is doing that might influence both productivity as well as creativity. And then we add health on top. And so all of this can be related from material, building opening, sustainability, where we sit in the city, to how we actually design the layout of a room. So I'd love to see that incorporated.
Thank you, Yi. And just like at Building Smart, we are trying to blend in vertical and horizontal and urban scale. Similar questions would apply to those drivers, those passengers, those of us kind of like on Caltrans highways or any infrastructure, right? To also think about how we serve the ultimate public and what we do, as Steinar and Stanford also mentioned, the ultimate client objective of VDC. All right, so with that in mind, yes.
I have one last more important question after this one. So just for us to get in touch with you after the workshop today, if you have checked, possibly you can share the models to participate in the program, especially this pink one, if you have checked for that option. Then the next question is, let us know your name and also maybe type in the use case that you are interested in. Your input will not be shown on the screen today, so we'll give you about 30 seconds or a minute to input here so that we can reach out to you, talk about what the next steps might be, what the use cases that you are interested in might be, and the requirements that we want to write down.
I think in general, it's not only providing BIM or contributing IoT data, but it's any follow-up that we can team up with you. Feel free to put in your names and the areas of interest that Building Smart USA would love to follow up. Good. So while that question is open, I would also like to say thank you. Let me share my screen. Michelangelo, before you need to get going, do you want to, or Mike Kennedy, would anyone of you like to say a few things? I only saw some chats, and I could not tell whether you can speak or not.
Tony can unmute Michael.
Oh yeah, we may need to unmute Mike Kennedy, among others. Or if not, feel free to help relay what he just said.
Now, can you hear me?
Yes, we can hear you.
Okay, I put in the chat. I was listening to the lady that just came up, and talked about her background and the human side, and trying to incorporate that in what we're doing, and it kind of resonated with me with the human factors aspect of highway design that we've been trying to get a better handle on and look at differently in terms of design from a safety standpoint, but also a communication standpoint. What are people seeing and not seeing, and what can we do to make things more visible and safer from just the human side of it. And I don't know, like I said, it's not a direct correlation to what she was saying, but I do think there's some similarity that, in a BIM world where you can do modeling and you can put people in a virtual environment and you can do testing on, what works and what doesn't work in terms of signing and roadway, roadway features, that there may be some benefit in terms of looking at what she was talking about. That's all I wanted to comment on.
Thank you, Mike. And also thank you, Mike, for joining Ian, myself, and many others representing ASHTO at the Building Smart International Summit, building upon what many of you have done with Building Smart on BIM for infrastructure, also prioritizing a lot of the use cases, summarizing it internationally with the International Infrastructure Room. And so we look forward to building upon those foundation and see how this sets of potential pilots we can do this year to contribute and converge with what you, Mike, Ian, and the broader team are doing. So thank you all. In closing, I would like to once again say thank you all. I think we have like 15 countries signing up, over 200 people sign up, and of course a room full of passionate leaders joining us here in the workshop. And also want to thank our co-host, PBL Lab here at Stanford, SciFi at Stanford, and also Building Smart USA, and also all the sponsors for making us possible today. It's okay. For the remote, I'll just voice over. And then for those of us, whether you're remote or local, there's a call. If anybody would like to join Building Smart USA in serving on the jury of the Building Smart International Awards Program, let us know. We are calling for jury duty on an international scale, and please join us. It's pretty fabulous. There are also a series of openBIM courses that Building Smart International, Building Smart USA, and Stanford are offering. So check in with us if one of you may be interested. And so, yes, we formally close. We have some information for the locals. And then, Ian, please.
Before we talk about those logistics, if we could just go back to the awards program.
Yes.
Smart International are still seeking entries for this year's program. They've extended the deadline till the end of this month. So there's still time if you have an exemplary example to share in terms of a case study to be recognized as part of the International Awards program, which will be a celebration in September in Norway at our next international summit. But we're always looking for good examples. Some of the winners, past winners, you've seen this morning. And it would be great to feature some of your work for those of us in the room or online as well in terms of future projects. Also, in addition to thanking ACCA for their sponsorship, I wanted to call out that ACCA have made available a very high quality set of IFC 4.3 files that we can certainly contribute to the citizen believing exercise. Again, based on some of the work we've seen today. So if anyone's interested in getting those files, I can be an initial point of contact.
Yeah, we landed right outside along Highway 280 here. Okay, thank you. And so for those of you joining us remotely, we'll resume again at 1:30 p.m. Pacific. For those of you joining us locally, just a couple more logistics. We have a lunch reservation at the Faculty Club. We did cap our RSVP, so about 24 of us will be joining us with 2 tables at the Faculty Club. If you're not sure whether you have RSVP or not, just let Janice or me know, and we can reconfirm. For those of you who are not joining us at the Faculty Club for lunch, there are lots of options around campus, such as the Cooper Cafe, just 2 levels down, plus many other options. For those of you joining us at the Faculty Club, I'll do a little bit longer journey because it's more visually appealing to go through the main quad, the Memorial Church to the Faculty Club. We'll try to pack up because I think some students may need to use the room during lunchtime. So please pack up with any valuable items, please bring with you. But then we'll be back in the same room and we'll be joined by Renata Futter at 1:30 p.m. Thank you all for joining us again. We'll be starting in a minute or two. Testing, can our remote participants please say something? I want to do an audio check here. Like,
We hear you, Calvin. We hear you, Calvin.
Tony, please keep on saying something. We need to adjust the audio.
Oh, okay. Well, very good. I hope you all had a great lunch break. There are many of us here in Cyberland waiting with breath abated for the resumption of the proceedings.
What's the sound check? Can you hear us from the back when Tony says something? Okay, good, good. All right. So final call for those in person, coffee and tea to get refreshed, and then we're going to get starting again.
First of all, I want to ensure how to consider people when it's been settled a lot of times. I don't know how you do this. They don't actually know, but it's good to see them with support under that.
Oh, yeah. Thank you.
Calvin, the audio is quite garbled if it's something we're meant to be hearing.
We are going to start. We're going to start very soon. Indeed, those are some background noise.
Oh, okay. As long as it's just hubbub, we're fine. Thank you.
Good. All right, welcome back. So welcome back to those of us in person, and also hello or welcome back to those of you joining us remotely. So as mentioned this morning, we saw the Zoom presence of Dr. Renata Futter as we celebrated the 30th anniversary of her Global Teamwork class. And now let's welcome Renata to join us in person.
ChatGPT that spoke this morning, I promise you, and hello everyone again. Actually, I should stand here so people can see me.
You can stand here, they can see you too.
Okay, great.
Otherwise, they can still hear you.
And everybody can see me here. You know, I'm one of these shorties. They should have a platform for us. So hello, everyone, and I hope you can hear me as well for all those in cyberspace. That will be okay. It is a pleasure to have you on board, and I was really impressed to see this morning close to 70 participants, cyber participants, and now a great group here that I'm meeting in person. They can certify that there is a Renata Futter. And I'm here to pitch to you a very exciting milestone we are celebrating in our department. And that is the 30th AEC Global Teamwork. And you may think, well, what's the big deal behind global teamwork? We are all doing that, right? How many here have not been in distributed teams. Distributed in the literature and in practice is defined as 30 feet distance. You can be co-located. Anyone? Is at arm's length working with everyone on board. So that's the reality we are all experiencing, and due to COVID, there was a global social experiment. We all were globally distributed. 30 years ago, I was the unicorn, and I was really having this vision that we need to prepare the next generation's workforce every year continuously for distributed work. And actually, the AEC industry and our projects are by definition distributed, right? Because at least the office and the construction site are not happening in the same location. So 30 years and counting, and I'm really super pleased to have among you two of our alumni. And I'm not going to put you on the spot, but it's always great to see our alumni become leaders, change agents, and innovators, entrepreneurs. We have continuously explored new ways of working, reimagined collaboration, developed new technologies in the lab and at SciFi, integrated them into education programs. And our sandbox, as you heard me say this morning, is the AC Global Teamwork I started to teach 30 years ago, thanks to a visionary director, the first director of SciFi, Paul Teichholz, my colleague, who sends everyone greetings, as well as tremendous colleagues in my department and across the bay at UC Berkeley, because Stanford doesn't have an A, meaning the X. And we love to partner. I strongly believe in harnessing knowledge and fostering creativity. And in addition to our faculty partners, my partners in crime, I had also the fortunate opportunity to have some industry visionaries. One of them is in this room. Ian Howell and Jim Malloy were at that time at Autodesk. And Autodesk was one of the industry sponsors of the NSF Synthesis Coalition. And they were our SciFi liaison from Autodesk. I get goosebumps because I proposed this vision to bring together students from architecture, structural engineering, construction management that are educated in silos, just like our industry, in different departments. They never meet each other. And I submitted a seed project at SciFi. And our industry has to evaluate and decide who is aboard. At that time, industry decided education is not our business. So on a scale from 1 to 5, the assessment of my seed proposal was 0.1, thanks to Autodesk, who said, we are on a mission. And thanks to Paul's vision, he vetoed the decision. And we started this journey. Now, 30 years ago, I could not have imagined we will be here. And it is a tremendous journey. And we want to celebrate the success that we accomplished together with all our university and industry partners, it has grown into a tremendous, vibrant learning network. And my belief is that we know more than I, and we all learn. So it's not just industry playing an active role in educating the next generation, but also being inspired by our students. And so tomorrow we are going to have an all-day event, which is coming under the umbrella of this year's theme. So every year I define a theme that is inviting the students and our partners in industry and academia to think outside the box and suspend judgment and address the current opportunities, challenges, and integrate the latest knowledge and technology into learning and work practices. And so in the face of the current climate change that is coined, as you all know, Code Red for Humanity by the UN based on the IPCC report, and all our ongoing efforts, the theme this year, as you can see here, is the future of work, as everyone is questioning in all the companies, related to a journey, a metaverse journey for a better world. So it's not the technology that sits in the driver's seat, but how can technology actually help us design, build, operate, maintain, and reuse with zero waste a better built environment. And consequently, in doing so, this year we have 30 students coming from 9 universities and the 5 disciplines: architecture, structure, and mechanical engineering, you know, all those MEPs that mess up everyone's life, punching holes into the structure, taking away clear space from the architects, and being the most expensive and complex system that needs to be integrated with the rest, and construction managers, as well as lifecycle financial managers. So the risk and lifecycle assessment. So they are distributed over 4 globally cross-disciplinary teams, and they live and work together from their respective universities. Stanford is an international campus, but once you come here, you become a Stanford student. So they are challenged by the typical 5 discontinuities in global teamwork, cross-disciplinary collaboration and communication, not just here is my design, good luck, build it. Second, embed new technologies in their daily work practice, and that is my latest bumper sticker message. Don't look at all the shiny stuff, technology. Question always, is it embedded in the daily work practice and in the business workflow process? If not, Darwinian forces will apply to technology, and when crunch time comes, it is forgotten. Even though heavy-duty investments are made with a vision. Third and fourth, managing task interdependence over time and space. And the 5th dimension, which is the most complex, is multicultural teamwork. Understanding how you can actually harvest and leverage knowledge and perspectives from different parts of the world. think global, act global. So with that in mind, all the teams are tasked not only to design and virtually build university buildings in challenging locations, addressing local hazards like flooding, hurricanes, earthquakes, but also learn how to embed new technologies and address this theme. Under the umbrella of this theme, I define, together with partner industry sponsors, 3 challenges that complement the big picture related to sustainability, IPD, integrated project delivery, and technology. So, the sustainability challenge sponsored by Swinnerton and AR Green Consulting this year is inviting the students to propose solutions as part of their design and construction, their VDC approach, to address scalable sustainability. Not just your building, but how can you scale? And how do you measure scalability? So KPIs, metrics, goals, metrics, and results. The IPD DPR challenge this year complements the scalable sustainability challenge, and that invites students to address sustainable design and construction for decarbonized buildings as products. So digitalization, prefabrication, robotics, AI, generative design, all in action. Last but not least, together with Bureau Hampel, the youngest challenge among the 3 is addressing this year, leveraging technology to build a better built environment. So, keeping this in mind, I designed for tomorrow an opportunity to learn for everyone, as all the students are back to Stanford. And if you want to know how to actually make it into the class, I can tell you that. It is really an amazing group of students, strangers that met in January and learned how to become a high-performing, globally distributed project team. And in 4 months, if you come tomorrow, you will see what they accomplished. And so, because it is a special year and we want to celebrate not only this year's students, we want to celebrate the journey and thank also all our partners, industry and academic partners. It is, I hope, going to be an inspiration for everyone, as I structured the program to interleave the student presentations, where they will present their product and their process, with panels that bring back to Stanford alumni of the AC Global Teamwork class that are now out in the real world, entrepreneurs, startups, like the first 2, and I could have had a whole workshop just with AC alums, leaders in academia, so were my PhD students, and they went out to Europe and to Puerto Rico, and they emulated the program there that bridges different departments and different schools and different disciplines together. And leaders in industry who are now senior CXOs in companies and pushing the will close the day with announcing the winners of the 3 challenges, and then have a reception, celebration, and networking, which is always a lot of fun. Quick note, because I just finished at midnight, the report to my colleagues from AR Green Consulting and DPR and Bureau Humboldt, letting them know what the results are. And the results, the assessment is what we call validative assessment. So you all went to school and you all were evaluated and got a grade based on formative and summative aspects. So, you know, are you proficient with the material I taught you? And you have a project, an exam, and you get a grade. Hopefully you still remember what you learned. Validative is an external evaluation of what the students have accomplished. And for each challenge, there are evaluation criteria, scoring points, and 23 mentors reviewed 45-minute video presentations to assess the teams and submit their evaluation anonymously. So I don't know whether Bob decided on subgrading, and the results came. The deadline for the mentor judges from, you know, pick your favorite company, probably it's on the good list. And so I already know who the winners are, but no spoiler. So tomorrow, and if it cannot come tomorrow, I invite you to visit in June the pbl.stanford.edu website, the project gallery, where you can actually see 30 years of projects, just to get an idea when we started, and there are some gray heads here. You remember it was AutoCAD R12, and that's what we used, and more tomorrow. And stories. And we are now in an immersive world where our students take their integrated BIM models and do visual clash detection in VR, because everybody has a Quest 2 and access to Iris VR and Fuser. And you'll see tomorrow, I really can wave my hands, but seeing is believing. And so come tomorrow, and if not, go visit the website and be inspired, because that's what we hear from our industry mentors. And we have this year, the group has grown to close to 80 mentors worldwide, so not just the Bay Area. They tell us that they were inspired by every year, and then they took some ideas and brought them into their projects and into their companies. So there are other past project YouTube videos. The videos emerged due to the pandemic, and we like to keep what good lessons we learn. And that's one value that we can share, not just PDF files. There is so much more behind simple PowerPoint slides. The stories are amazing, and we all love to learn from our students who are the digital natives. And every year they continue to amaze us, and I look forward to see many of you tomorrow. It's on the second floor, and some of you know where Cycli is, Center for Integrated Facility Engineering, our interactive room, where we also take advantage of the keyword interactive and immersive. So it will be more than one screen. Because I believe in being immersed into the content. To quote Ian Howell, and I will be done. To quote Ian Howell, when we were 30 years ago in Paul's office, and we were showing him our semantic modeling extension that we integrated with AutoCAD R12, and he was like, of course. It's the data, stupid. And he really was an amazing champion, and he continues to push the envelope and really provide value to our industry through his leadership. Thank you, thank you. And thank you, Calvin, for being my partner in not just having 1 day, but a 2-day inspiring visit for everyone who came from close by or far away. And have a great afternoon. I will have to go take care of all the moving parts for tomorrow. But it's all recorded, and I will look forward to have a look at all the amazing presentations, because the lineup is just like that. You are in the candy store.
So thank you so much. And amazing stories. Heard about that, but seeing both of you in person, reconnecting what inspired what we have, what we're going to see tomorrow from 3 decades ago. And more importantly, both of you are still running as energetically and even more inspiringly as ever before. So thank you both.
Renata, you mentioned a website. Do you have, or can you tell us what that website is?
It's very easy. So I'll spell E like in Peter, B as in Ben, L as in Larry, Stanford.edu.
Perfect, thank you.
And you can then click on Project Gallery. You'll see the challenges. This year it's the 17th Sustainability Challenge. The 14th EPR IPV Challenge, and the 5th Bureau of Technology Challenge. And every challenge is inviting you to actually try and address your projects. These are not school challenges. They are really rooted in the challenges that we see in the world, in our industry, that we are really responsible to address. Have fun being creative.
Calvin and I have just discussed that next year there will also be a Building Smart Challenge.
Oh, all right.
Thank you, Renata.
Thank you.
Thank you, Ian. All right. So once again, thank you, Renata, and all the best for tomorrow's celebration. Many of us will be there. One of the reasons why it's a workshop, 20 people, we are glad we have more than 20 people, is because we have a 100-person capacity tomorrow to join us to experience that live. Before Building Smart, I think Renata already has 80 people. So we need to keep it to be around 20 people. So thank you for those who can join us in person.
Yes, so my grandmother used to say, if you want to come to dinner, no worries. Add some water to the soup.
All right. We'll bring our water tomorrow. Yes. Thank you, Renata. And indeed, and I think we connect with Renata tomorrow or later today. But indeed, can we not only learn from the students, from the mentors, from 3 decades of global teamwork? Can we, as a community, join forces, challenge one another, and come up with a Building Smart, with a Caltrans, with your organization, Genentech, challenge, and what we can do to challenge the next generation, as well as ourselves, to advance together. So, so thank you, and thank you, Ian. Amazing stories about what kind of like seeded all these amazing contributions 3 decades ago. So next on the lineup, we are very glad to have Caltrans team to be presenting to us. So thank you, Mark. Thank you, Aaron. The floor is yours. If you don't mind, come over here so that the video can be, we can feed your video to the remote participants.
Sure. You guys want to have that? Just look at that now. It's like get on over.
Up to you.
Yeah, well played, Aaron. Let's see. When I was looking at it
If
earlier,
we get really cozy, we can both be in frame.
I was thinking about it. We should have brought your Skydio. It could have distracted us the whole time. All right. How y'all doing? Good. Yeah, doing cool. All right. So before we get into it, stay here. All right. What do you do, Brian?
What do I do?
What do you do? Come on.
I work in design construction. What do you do?
What do you do?
You're presenting
design. What do you do? Fast.
Software and
Fast. Go. 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 Go.
design.
Go. Go. No one said value. No one said add value. It's interesting, right? Like I've been, there we go. I've been trying to do this. I'm trying to do this over the last maybe 3 or 4 months of us coming in and having discussions. And it's interesting that no one's first thought is add value. We instantly go to tasks. We instantly go to domain. Instantly. Why do you think that is? We're talking about it all morning. What are we doing? What's the whole point of this? What's the whole point of it? To what? Add value. But when you get asked a question like that and it's rapid fire, you don't have a chance to really think about what you're going to say. The first thing you say is, I think it's because of the way you asked the question. Okay, let's get that. Why? No. So let's play that. So everyone saying like we're not relaxing garbage. Yeah. Well, I have a sneaking suspicion that some of the same results. And we've asked that question different ways, different groups. And I think what happens is we get so fixated on our domain. And part of what the conversation is going to be about today is to try to see that there's more similarities between domains than there are distinctions. Okay. And that's the whole point of that exercise. And really, I think that overlapping center of everything that we do here when it comes to infrastructure is that we need to be adding value. Period. We need to be adding value. We need to be leveraging existing value in new ways, and we need to be creating new value. I think that's kind of what it all comes down to. And as you listen to all the presenters this morning, I think that was a common pattern. Can you all at least agree with me there? John, right? Go. I'm talking to a surveyor, man. That's my lifeblood right there. That's like hurts my soul. So before we get going, we really want to say thanks to Calvin. Calvin, thank you. And Janice. So let's give them a round of applause. The coordination, very good job. Oftentimes the coordinator doesn't get a whole lot of praise. You did a great job. Your emails were very straightforward, easy to follow. Love being able to upload all the data. It was just great, right? Great experience from the very beginning. And we also want to say thanks to Future Insight, Datacubist, Trimble, Stanford, Alice, and ACCA, all the presentations that came before us. They were pretty awesome, right? Let's give them a round of applause. And then we're gonna, thanks to ahead of time to Michael Baker and Esri. We've ran into Marc Goldman a handful of different times now, so it's fun being in the same circle with Marc Goldman. I don't know if he's on right now or not, but shout out to you. And then yeah, we can't forget the legend, the myth. I'm not gonna remember this time, but Ian Howe. So Ian, thank you so much for who you are, everything that you've done for the industry over the last 30+ years, and I really appreciate you. Ian has been kind of like a mentor from a distance for me, or a source of encouragement. First time we've ever met in person. For the last 2 years, if I've got a question or I need a little pick me up, right as I'm getting hit with the bureaucratic punching glove, I can call Ian and get a little pick me up. So I just want to tell you how much I appreciate you, and I think we can all share a little appreciation for everything. So good morning. All right, so thanks for bearing with me. So what do we do? What do you do? What do you do, John? And hopefully we're adding value, right? So my name is Marc Counts. Let's go to the next slide. All right, there we go. So Marc Counts on the Chief Office Surveying Systems out of the headquarters division for office land surveys in right-of-way, based out of Sacramento. I've got 18 years experience. I like to say I'm field tested and office approved. So I got 7 years as a field junkie. I got 7 years as an office junkie, and I got about 4 years as a policy and systems creator. So that's a little bit about me. married with 3 kids. I'd like to say happily married. It's you know, I love my wife, with my kids. It's just like the best part of life, right? That's what makes life so good. Having those healthy kind of relationships. And then I love writing music. Love writing music.
Yep, I'll go next. Aaron Chamberlin. I'm with our division of construction, ops, performance, and innovation. So like Mark, I also came from the field, a little bit more field, a little bit less office. So I ran projects up until about 3 years ago, until I came to our headquarters division and started working on trying to implement, more advanced field technologies for our division. So again, happily married, 2 kids. I like boating. So getting drugged behind the water at 25 miles an hour is, if that's your idea of fun, you're my kind of person.
And he's really good at it. I've been out with him multiple times. I'm not that good at it.
Okay, so we'll start. Okay, what is COMS? So COMS stands for Caltrans Offset Lifecycle Management System. Nothing all that intricate there. It's our great acronym. I'll jump in here. Okay.
So Caltrans Asset Lifecycle Management System. And so at the end of the day, really what COMS is we're trying to come up with ways to better leverage the value that we've already got and create new value. So if you take anything away from today, what is COMS? What do we got? Value. But we're trying to better leverage the existing value, and we're trying to find new ways to create new value. It's actually like value. It's really important that we all get this. And so right now we're really in a discovery mode for this. It's kind of like we've been kind of panning for gold. Okay, we come from Northern California. There's a lot of gold mining up there. So Brian, can we play? Sure. Will you play with me? Sure. All right. So me and Brian, we're out there. We're mining for gold in the Feather River. We're out there all day. And then who else do you got? Jack. Jack really wanted to come out with us. So Jack, me and Brian were out there. We're mining for gold, and we all get some real nice nuggets, beautiful nuggets. Aaron happens to be out there with us too, and he's mining for gold. We all got nuggets. So we all put our nuggets on the table right here. Aaron comes out with his iPhone and takes a nice 3D scan of the nuggets. Okay, real nice 3D scan, nice mesh. He takes all the nuggets and throws them back in the river. He goes, all right, let's get out of here. We're done. How do you feel, Jack? We're gonna kill Aaron.
That's not an uncommon statement.
I'm gonna kill Aaron. That's the best. How do you feel, Brian? It's a long surprise. Surprise. But right, don't worry about it. Like, take that to the pawn store or something. Don't buy that.
Yeah, we got a picture of it.
We got a picture. Well, we just have a picture. And so what we've kind of found is this takes us to our problem statement. And what we've identified is that there's just a ton of digital and organizational gaps. One of the reasons why we like to talk about being happily married is because the quality of the relationship is just as important as the relationship itself, right? Just because you have a relationship doesn't mean it's going to produce the fruit you're trying to get out of it. And that's the same thing for organizations. Organizations are organic, digital, mechanical relationships all the way across the board. I think what we're trying to do is trying to find better ways to organize those basic elements so that we can either leverage our existing value or create new value. Does that make sense? Does anyone want to challenge on that one? No. Not yet. Okay. Right. So the solution statement, this is what's fueling us. Is really it's a simple statement, a simple concept. We've heard these concepts talked about throughout the morning, but really what our goal is a better connected Caltrans. Yeah. First, we're focusing on project delivery. We have a few project delivery. We have structures right here, construction. We have survey right here, design. We got design right there. So COMS is first focusing on better connecting project delivery, and we're in partnership with another initiative called BIM-GPT. And then the next goal will be across programs. So we're not happy. We're like, I've got a tattoo right here that says enough is a myth, and it's backwards because I know myself. I'm insatiable. That's the truth. I'm insatiable. I always want more. And so once we kind of tackle this little mountain, then we want to see how we can better connect all the programs. We want to connect legal, HR, not just operations and maintenance, right? Like you hear BIM, you think construction, cool. You think design, you think structures, you think sexy bridges, and then you pepper a little asset management, right? It's kind of BIM. When I hear people like that, but what about our lawyers? Don't they need access to that data? Don't they actually have their own data that can get integrated into that asset? What about our human resource employees? What about them when they're doing their cases, workers' comp? Don't they need access to this data? And then that's not enough. And these won't be systematic, these aren't going to be chronological. These will all be kind of working in and out, more like a cyclical sort of approach. But then across the ecosystem. Any contractors in here? Anybody contractors? Okay. Anyone from well, we have one. So you're part of our ecosystem. Any software development? You're part of our ecosystem. Any students in here? Part of our ecosystem, right? And so this idea of okay, even just starting to get a better understanding of what is our ecosystem, really what is it? You know, there's so many layers of systems. I mean, just right here, if we were to try to diagram all the layers of systems just in these 3 tables in a back row, I mean, we're gonna need more whiteboard space, right? Okay, so. And then here's my last slide, and then we'll hand it over to Aaron. And then our approach. So what we found is, so far, we've been at this for about 18 minutes. This has to happen somewhat in this order. We are fine, we played with this different ways, and this is a pattern that has yielded the most gains for us. Starts with people every single time. Everything we do is done by people, for people, through people. By people, for people, through people. Then it goes to platforms, then data, then systems. And so that's our basic recipe. And I'm speaking confidently in this, but I want you to know this is very much a discovery process. This is just what we've kind of found as we're playing with different recipes. But it seems like this is the best recipe for us so far.
Okay, moving on to the people thing. So this may sound simple, but all of us inherently are information professionals. We may be in very different disciplines. I think at one point I tried to look up all the different Caltrans classifications within our, various types of people who we have working for us. And there was like over 300 that I could find, and I still wasn't done looking. Anything from, people doing maintenance work, people doing, lawyers, all of this stuff, right? So here's just a small listing of what we have, accounting, aeronautics, traffic operations. It seems like every couple of months, and I've been with the state for 16 years. We have 22,000 employees. I find a new division that I didn't even realize existed, or some new office that we didn't even realize existed. What data do they have? Are we, is that of value to connect to?
Well, you're just looking at this. How many people up here that are really focused on making sure your civil rights program is flourishing? Is that has full access to all of your asset information? Anybody? Raise your hand. Nobody. Okay, shocker. All right.
So next on the people slide, so this is one of the things that we're trying to do is really start to work with some of our other partners. In this case, we're showing some of the other DOTs that we're collaborating on this with. Again, this isn't super official. This is a very loose group of like-minded individuals that we have found kind of.
What's the phrase? Impact.
Impact junkies, right? There we go. So
by the way, what's the y'all? You remember that one? Impact junkies? Raise your hand if when you wake up, you're driven by leaving the place a little bit better off than we found it. Just raise your hand if that's you. If that's when you're when your first lines of motivation, you unfortunately are impact junkie. And we want all of your contacts.
Yeah, you'll see some big ones in here. We got Montana, we have Utah, we have Oregon, we have Texas, we have Minnesota. We made some recent contacts with Alaska the other day that hopefully going to be joining in with us with these efforts. But again, kind of a grassroots effort. And here's kind of the more unconventional one is, we're looking at these. I don't know.
In particular.
For us in particular, this is a very different paradigm. So historically, Caltrans has used the word vendor.
Yeah.
So that's
vendor. Anybody?
Yeah.
You can call it a vendor, right?
Yeah. I was gonna say, do you sell hot dogs on the side of the street? It's we're looking at this as trying to get away from that, paradigm of transactional. We're not just buying a product and they hand it to us and we use it, right? It's not a hot dog, right? It's a bi-directional relationship, i.e. we're not calling them we're not calling them vendors, we're calling them software development partners. So
yeah, this is and it is important for the record. So we are equal competition. So each software development partner that we have went through a very rigorous competitive bid system, and they had a fight for that seat at the table. Yep. And as some of these bid processes can last up to 2 years. So
or more.
So they put in the work to be at the table. But it's real. We got to make sure we're real clear. We're not showing papers or anything like that. People have had to compete. Organizations have had to compete. And so that was even more reason for us to want to challenge our own paradigm, right? It's interesting. If I look at land as a transactional asset that I'm going to consume, guess what? She ends up starting to kind of she'll respond to the way I treat her. But if I say, Brian, I'm gonna look at you as we're going to the future, you and I doing this. You're gonna notice the behavior, the outcome, the product, the fruit changes throughout. We think this has changed dramatically. But it started with us having to be willing to take a second look at the people that are part of our ecosystem. Started with us having to be there.
You know, and the last component there is, you know, again, our contracting community. So, you know, we don't build the roads ourselves, right? We just administer these contracts. We just do some of the design work. They ultimately have to build it. So, you know, again, bringing them in as part of this is going to be very crucial. Next slide is kind of this was kind of our first comms summit that we held last year. So I think we had over 40 individuals from, you know, again, major software development partners that all came together in the same room. We sat down from all over the world. We had people there from, you know, from Europe and from New Zealand and almost everywhere in between, all sat down in the same room and we started to work out, you know, the problem.
Well, what's interesting about that too is I love that add more water to the soup. Like I love that because in the middle of this 3-day conference, we had everybody in my house. Barbecue, big barbecue. And we had over 60 people there from Microsoft, Trimble, and there's a few phrases that got shared with us throughout the whole evening. Number one, no one has ever invited us to their home. Never. I've been in this business for 30 years working at Autodesk. Not one client has ever invited us into their house. You know, it's like,
yeah, again, the people.
But it's like being willing to challenge how we see people, right? And so when you challenge that presupposition from a hot dog seller to an actual partner that you're going to build a future with, guess what you start to do? You start to do things differently even on your side of the street. You start to open up your home, right? And the other thing I said is, this is the first time in our experience that anyone's gotten all of us together. Safe, Cancel, Trimble, Autodesk, Esri,
Microsoft,
all under one roof, all under one vision. And so this is part of what's innovative for us. But again, we started with the people. It's crucial. We start with the people. And then platform interoperability. Next one.
Yeah, so I mean, again, this is one of the initial focuses for us is, again, starting to work with primarily 3 of our software development partners, which started with, again, Esri, Autodesk, and Trimble, working towards data interoperability. You know, can we actually push data from one platform to another and actually have it end up in the right place, in the right format, without losing data fidelity?
Yeah. So here's just a quick graphic on comms. All right, so you got the quick and dirty answer, right? What is comms?
Asset lifecycle management for Caltrans.
True, and then what's the purpose of it?
Value creation.
There you go. All right, so now we're gonna go down a level, right? And we know it's people, platforms, data systems. All right, so now here we are. So this is just a very rudimentary kind of example of what we're looking to build, what we're in the process of doing. And these look singular, but they're not. These are more of like data centers. Think of these more like data centers, right? It's not just a single server that's going to serve all the stuff. But what we've identified, there's 2 main areas of the house that do asset collection and on like the centimeter level sort of spectrum. Surveys, and then construction is becoming more and more a part of that process. So if we want to build a system that everyone can access and that can understand, right? It's like if I were to give you a traditional survey drawing, if I showed it to my 5-year-old, they'd be so confused. They see colors, they see all these lines and squiggly circles. And if I show them a bridge design from, you know, before Lynn's time, you know, before the superstar showed up, just as equally confused. Like, is that a tree? Is that a bush? Is that whatever? But when you actually show them something like a digital twin, my 5-year-old can tell you everything that's in that digital twin, right? But in order for us to get there, we realized we had to standardize our data, centralize our data. And so this is, that's right.
You want to go to that one?
So this is our attempt of basically doing 2 things at once. Learning, basically centralizing our data. So getting off the DWG crack pipe, you know what I'm saying? Like all those little databases, all those little containers, or DGN, fill in the blank. Getting off of that, getting back into more of a central repository, a data center. And we're still working on this. We're not entirely sure what that looks like. Aaron was able to secure about $400,000 worth of expanded server space for us to actually build this system on, which is going to be helpful. But even for us, that still looks more like a stepping stone. But as we build these out, what you're going to notice is our CAD platforms, we will have true interoperability. So as that field surveyor is publishing to this data center, This is all out off the shelf, by the way. These tools just dropped like a few months ago, and we're going to be reiterating through the summer. That's the other thing we love about this. Not just Caltrans gets the benefit, everyone in this room gets the benefit. If you use Civil 3D or you're using Trimble Business Center, anyone around the world is going to be able to do this right off the shelf. No more middleware, no more having customization other than configuration costs. So that was the other part of this, right? Is approach the problem in a way that more people can benefit from just Caltrans. How often have we seen that, DOTs, right? They just solve a problem for themselves. So what about the other 49? So that's the other cool byproduct of this approach. But so what we're going to be able to do with all of our centimeter level accuracy data now from our data centers is be able to push and pull without losing any sort of data integrity and being able to update, save that. So that means if I've got a surveyor over here that just added a new data set, new typo data set, publishes it to our data center, then that CAD operator is going to be able to bring that in right off the shelf with our configuration. And then if that CAD operator finds a problem, Ryan, because your crew told me the yellow stripe and it was a white stripe. I'll talk about that later. Don't worry about it. All right. John's crew is going to be able to in the office fix that, save that back, and it'll update your authoring software. Okay. And then you're going to see a similar setup for construction. And then the idea is we're working on some tools right now that'll be doing basically data crawling. And from there, we'll be working through these system of records and bringing that data up into what we call our digital geospatial ecosystem. Some people call it digital twin. We'll talk about why we decided to rename it for our purposes, but okay.
Yeah, so centralize the data. So this is, again, there's the comms effort really is a bunch of smaller sub efforts that are all kind of working in the same direction. So this is our DPC, our digital products catalog prototype. So right now, really the most defined standards that we have that everything is running off of right now. So we've got 900 plus projects worth about $12 billion under construction right now. They're all based off of an existing set of standards, which is predominantly design centric. So the way our survey feature code libraries work and the way that feeds data into our design platform is relatively centralized. So that's the best set of standards that we have now to work off of. So the idea is, right now, for example, if Mark has to change something in our, for example, our survey code library in that channel. So again, these are all broken out by domain. If we have to change something in our, for example, our Trimble Business Center feature code library, you have to manually change all of those templates in Civil 3D to match.
Shapefile import setting, description sheets.
And it's a manual process.
3 different templates, and then you got other people maintaining their templates.
Yeah.
These guys get templates.
Yeah, so it's a nightmare to manage. So the idea is, hey, can we centralize the process of managing the templates from a top level and then basically distribute those out? And so that's the idea behind the digital product catalog is first to be able to distribute out by domain.
And then put
them to work. Exactly.
Database with standards. We've seen those. Zheng Build Smart has a nice data dictionary. Beautiful. But we haven't ever actually really seen anyone then take it the next step and say like, and if you've done that here,
yeah, tell us.
Line, because you can save us a lot of time.
Yes.
But this is what you and I were talking about lunch. Like, what we're trying to do. The reason why we're building this is because we want to basically be able to. Aaron's going to do the next slide.
Yeah.
Be able to from that command center, be able to maintain all of the different sort of template products that we need
CAD templates, design templates, survey feature code templates, all these other downstream products.
SEMA, right? How nice would it be with one fell swoop to basically get all of this stuff output?
So that's the concept. It's still a proof of concept.
We got the feature library done.
We did get the feature code library done. So we've done some test integration. So it looks like we can reach into Quadri right now. We can reach into the Building Smart Data Dictionary right now with the Open API.
Well, what's interesting is we did go to some of the larger software companies and asked if they wanted to. I thought for sure, as Esri's on here, I thought for sure Esri would have been interested in this. They're the database, right? But it just didn't really fit right now into the roadmap. So we're like, well, what the heck? Let's figure it out.
Proof of concept.
And so we showcased this about 3 weeks ago, 4 weeks ago now, something like that, at a peer exchange. We had about 8 DOTs down in LA. And we were taking orders, right? Montana's like, oh, I do the same thing you have to do, Mark. We want that, right? So the idea of having a data dictionary centralized and access to an online interface is not new. but then taking it and actually using that BIM server on the back end and starting to create all of your template products. That's in the DOT space, at least. That's a pretty neat thing. So,
or so we think. We haven't found anybody else who's done it. And if somebody else has this already done and they want to give it to us on a silver platter, we'll take it and we'll shut down what we're doing.
We're doing the best we can, right?
Exactly.
Yeah, I got an engineering surveyor trying to catch all the smart people.
So,
yeah, so then this is the next natural step. I think Brian would agree with me. So you've got a nice database set up, you've got a nice interface set up where you can interact, templates you can update and produce with your schema. But we need a way to make sure that that schema represents the needs of the entire department. Again, in our minds, we're thinking these data stewards aren't just project delivery. Right? We're talking all information professionals, includes folks like HR and legal and stuff like that.
Environmental, legal, exactly.
Yeah, like if legal's got a case, a tort case on this accident, what kind of data do they need? What's their scheme? What do they have to have access? All right. Any questions? It's after lunch and we've been talking a lot. I'm almost asleep. Just listen to myself. You all right?
I'm awake.
Are you awake?
I'm awake.
Okay. System. Let's go on to the next slide. Okay, so here we go. So really like we like to bucket things in like 3s or 4s to help us just remember it again. Surveyor and engineer walking to a bar, right? We like to split. So centralization, vision, standards, data. So now as far as like, we realize that we had like part of our mission now is centralizing all 3 of those things. So the vision is got a lot of traction now in Caltrans from the top down. So we feel like we've done a pretty good job of centralizing that vision. Our chief of innovation just got interviewed 2 days ago?
Yep,
right?
2 days ago.
A national infomercial company on comms. So I think the vision has been fairly well centralized. But now we're working on the centralization standards.
Yep.
But next the data. And so that's where comms, right? New ways to connect people, platforms, data, and systems, new ways to partner with industry to create new tools, products, and accessibility. And then, but here's kind of like the holy grail, or this is the top of the mountain experience that we're trying to get to. And that is to create a sustainable. And it's interesting when you put words together, we've had everybody on the comms team go through the statement multiple times, and it probably took about 3 or 4 months where everybody was happy with it. Because when they're partners, you get their buy-in, right? They're not partners on demand, not partners just when you want them, they're partners. And so from software communities to Caltrans to all across the board, create a sustainable and future fluid digital geospatial ecosystem that dynamically and virtually represents California's physical world over time. Love that presentation. Was it ACCA? ACCA?
Yeah, that was cool.
Michelangelo, right? I was like, I heard the angel sing. Anybody else? Or was I the only one? I was hearing the angel sing when I was looking at some of that interface. Like, oh my gosh, that's our top of the mountain.
Yep.
That's what we're trying to get. We're trying to get there. I keep going. And so compliments to District 4. Coach Lingari right there. One of our BIM managers.
That's actually 3 miles that way. This data is from the San Mateo 101 project.
San Mateo 101, and so Courage partnered with Esri to create this as sort of like a proof of concept of an Esri scene, just so we had and we like it. It's a great visual aid for folks to kind of experience. I got to get some visual aids from Michelangelo. That was the jam. I cannot get over that presentation. But again, this is just another way to visualize what we're talking about. Another group that I feel like from project delivery that doesn't get a whole lot of attention are the right-of-way folks. The people that are actually out there making deals with the public. Hey, got this news. So here's your property line, but he's got to come here, right? What kind of tools are we giving them to do their job better? How are we integrating them into this concept of BIM? Because they actually need it a lot. When they're dealing with people trying to convince you, like these are people's homes that they're negotiating. And what do they get? They get a pixel map from me
that I can't discern.
Right? Yeah. And it's like even some of these maps, like I was a surveyor. I'm like, hey, where's that surveyor thinking? Because they're so busy. All these little slices and slivers. So this is a big passion of mine. One of the user groups that I think is we will make, I think, some huge strides with this group, I think, as we build this DGE. because now they can start to implement augmented reality, not start to actually show the folks they're negotiating with what that's going to look like. Anyways, you got your locals, civil rights. This is a big thing for us. We're real big on equity and disparities and making sure that that our planning is socially responsible in building. And then HR design, you get the picture, right? All right, so.
Yeah, I mean, that's, again, that's, and that's, it's leverage existing value, create new value. Kind of moving on, kind of quickly. So what are we actually doing now? So
What's the next thing we're doing?
So the next thing we're doing, we have now these working kind of proof of concepts, basically prototype software that we're going to be testing. The tools are mostly there. So the next step is to actually take real project data and try to run it through the entire life cycle.
What do you tell about the project we're gonna do?
So we kind of selected an interesting project. Actually, Lynn did the design on this. So this is one of the first few projects that we have. Yeah, we actually have an LOD like 300 to 400 level BIM model for a bridge. So we don't do a lot of that.
Real tree. Excellent.
And it was also another kind of an interesting project because it was a new alignment. This is part of the Ote border major port of entry crossing project. So it's like something like a $2 billion large scale project. There was a lot of federal money that came into on it to make it actually occur. But it's kind of interesting in scope because we don't, especially as Caltrans, we don't build a lot of new freeway facilities anymore. It's one of the few times we're actually doing, new capacity, new freeway type installation
structure. The other thing that I love about it as the right of way engineer is there was a lot of interesting acquisition that took place.
Yeah, somewhat contentious.
PR was involved. That's information too, isn't it? How we integrate and educate the public. Yeah, so other than the stuff that we've been talking about this morning, model geometrics, bridge design, which is all great, fun, wonderful stuff. There's all this other stuff, all this other professional information stuff that took place on this project that makes it right. And so like our job this summer is we're going to basically go through it and try to find every data type, every data method, every data process, because it's just loaded with gold, right? We'll follow back up to that gold analogy, just loaded. Yeah.
It's actually called Siempre Viva.
Yes.
So in Spanish, it means live forever. And I think with the digital as-built and all the things we're going to do with this project, hopefully it will live forever.
It's awesome. It's fitting. Live forever, right? Yeah, that's a good point, Mike. So, and that's a good segue to, I think, our last slide.
Yeah.
And this is where we'll close. Has anyone heard of this analogy, the digital cathedral? Probably not, because we made it out. You guys are so creative.
We hope.
Trying to double out 3 miles, It seems like people resonate with it, especially folks that are far from project delivery, because they can get this. So like the folks that you're trying to say, okay, here's the benefit, this is why we $2 million, whatever, right? So cathedral, back in the day, could span very easily to 300 years. From inception to completion. It very easily span multiple generations. And oftentimes they did. And so what you needed to do to complete something like this is you needed to generate multiple generations of visionaries, hard workers, people that believed in the reason why you're doing what you're doing. All right, that's a lot. Imagine that. Hey, I got a project for you. Good news, bad news. Good news is awesome. It's gonna live forever. Bad news is you're never gonna see it complete. How does that feel? I think as engineers, we intrinsically just want to have finished product. I love driving by things, like my kids don't. They're like, hey, I built that. I see that channel right there. That was mine. Right? I don't care that. We kind of love that sense of completion. So something like this is a challenge, I think, just by nature for us, because it's like, wait, I want to cut the ribbon, man. I want to be there, right? I want to do the old stuff, like start it, cut it. But what we're finding is our work, we're going to measure ourselves. There will be waypoints along the way. Make no mistake. There will be returns on investment, all those acronyms you want to throw, all the business stuff. We'll have that, okay, as we go. But we're also trying to split the horns and say, we also have to think about this as a multi-generational project. If we do our job right, we will have the right kinds of people in place by the time we're ready to hand over the baton. We will have shown return on the current investment, and we'll have roadmaps for the next 20, 30, 40 years, right? Like here's a tentative map, knowing that it's clearly going to change as it goes. It's always going to evolve. But we have to think bigger picture.
And almost as importantly, we have to cultivate the next generation of people that are going to be coming to finish this work, right? So that's a huge gap that exists within our organization right now, is this total lack of workforce development that exists in this industry. I mean, we have something like 1,000 vacancies within Caltrans right now, people that we're trying to hire, and there's literally no bodies to fill those seats.
Yeah.
So, thinking in terms of that digital cathedral, we have to be, we have to figure out a way to, how do we get those apprentices to come up, with using that analogy, to learn from the master to continue to work.
Right, because we need to keep laying the bricks.
Yeah.
The other thing that also kind of comes to mind when we're talking digital cathedral, cathedrals often had an intrinsic purpose to them. Right, there's an intrinsic purpose. So that's one of our challenges, or more like we challenge you, like, what is your intrinsic purpose? What's really driving? That's kind of like the idea of a behavioral impact on saying here, right? And so that's going to matter. So when you're raising up that next generation, we've got a thing that we've stolen from someone somewhere, where it's like we want to be part of creating the pull culture, not push culture, right? Historically, I think our department's done a really good job at just bossing people around. Philip, you shall do this, right? We do it, right? We're talking about that a lot. You shall. And for us, like, this is another thing that's, I think, innovative to our team, not necessarily to the world, but us, is we're not going to mandate any of this. Not at all. It's awesome, right? And what's happened is it's actually kind of generated its own gravity field. And instead of us trying to mandate something, we've got 4 districts. Basically, I'm not going to say begging, but we want to be first. That's unheard of in our world. Whereas, like, right? And so what we've been able to do is take those 4 districts and say, okay, well, you can't all be first. But what we can do is pick one, this will be first, but the other 3, you're now part of the team. And we're all going to be boots on the ground together. But I didn't have to ask any of them to do this. They all wanted it. They reached out to me. So it's created its own gravity field. So from a change management standpoint, that's like a dream come true. And the way we're thinking about it is back to that goal analogy. If we can just work with the goal in the right kind of way and make it shine and turn it into something beautiful, it'll attract enough people to want to participate.
Any takers?
So that's where we're at. Thank you for your time. And thank you again, Kelvin. It's been a real pleasure.
Thanks.
Sir.
How long you guys rehearse this?
He changes signs on me about every time we do it.
Yeah, he never knows what he's gonna get. I always speak him up.
That's similar to your picture back and forth. You said that's what you said.
Right.
That's great. That's great.
Excellent. So once again, a virtual and also in-person round of applause for our value adding digital cathedral team. Amazing. Just actually reminding me of like what we have learned at Stanford, at Sci-Fi. I think it was about before my time, it was early 1990s. We have experts from Finland coming out, asking about some of the same questions like value and what can we learn? Are we adding value along the way? And that's how like Berkeley, Stanford look into the lean and the Toyota way and asking about those questions, asking about value add. And then fast forward for the last 10, 20 years, we had one of our sci-fi industry partners, Walt Disney Imagineering, Walt Disney, also asking, are we along the whole chain of like delivery, who are actually adding value? So it's very interesting. I think this is where we draw this kind of questions about the value proposition through the last 30, 40 years. And as we just learned from our Caltrans friends, this is going to be a lifelong, career-long, and generation-long journey. So that's why we are here. So I wonder if Ian, noticing that even when we were walking back from the faculty club, we had some discussion about how to work with Caltrans and maybe turn some of this to be a seeing it's believing, action-oriented, pooling value. So maybe Ian, would you like to summarize some of those thoughts and maybe we can see how the broader group may react to it?
Sure, we were trying to identify, were there any specific parts of this that we could take and collaborate on and do something literally by year end? So yes, it's a digital cathedral and it's a 200-year lifespan, but what can we actually get done this year, 2023, as one small piece of this big jigsaw puzzle in terms of helping Caltrans realize that? And we talked a little bit about this product catalog and how they need some ontology expertise. We know Dr. Aaron Costin from Florida University that's involved with the National Bridge Glossary for AASHTO, funded by Federal Highways. So suddenly we can now map Aaron and Caltrans together and work potentially to say, how can we actually build something out on that piece in conjunction with the partner DOTs, whom we kind of also know because they have their own pilot projects. George Luke's in Utah, who's promoting the HEAT conference. He's hosting the HEAT conference later on this year, and just gluing the parts and pieces together. So hopefully we can facilitate at least a couple of work items that can be additional kind of depth of discovery and just evolve the proof of concept to that next level. Obviously with support from SPI and others, and even tie in a couple of the international folks. So Mark and Aaron are off to Norway in September, and we've already said, why don't you add a day and go visit ACCA in Italy? And by the way, Rick's in the Netherlands, so when you're meeting with organizations, why don't you meet Nick as well? So just trying to network these people who are moving the needle, all to support and help Caltrans with their wonderful visions. So.
Perfect, perfect. Any other feedback from those locally or joining us remotely? I think the sound bites we heard is that, wow, what a creative group and what an amazing bunch. Fair you, I think it's certainly in everybody's mind. Any other feedback, reactions? So we also have a lot of other Caltrans colleagues. Feel free to also chime in. Yes, please.
Yeah, I have just one comment or question. With the kind of like the involvement of all the other potential groups that could, integrate with, this effort, they would need to know, like, what information do they need? How is it going to interface with what you're building, and how are they going to get access to it? And ultimately, that's going to make your delivery more expensive, right? And the return on investment comes when those stakeholders start taking advantage of the information that you're providing them. So for you, like, it's almost like cart before the horse. Like, if you're putting information together that no one's using, then it's just going to be more expensive, right? So how do you know that your partners are going to use what you create?
Okay, so I can take this. You want to take it?
I'll take it.
Yeah.
So I work with headquarters CAD, and I work with OLS, and I support the designers, and they support the surveyors. And so I'll be working with Mark and Aaron to determine the data that they're providing, what Aaron needs out of construction, and then facilitate Karush in providing that data to them, and then bringing it back in here. And so that's kind of like my job to make that work. So I'm already in place to help that happen. And then just a little bit of background. I wrote the first app for Autodesk for the sheet import tool, which was CSAC phase 1. So I'm intimately knowledgeable technologically on what the data is and how I can give that to Aaron by pulling it out to me.
So you're helping the end user understand how to interface with the information that exists.
Yeah, and Aaron's letting me know what data he needs from the design, so I can then mine it out of Civil 3D, put it into the database, and then Aaron can go grab it from the business.
Because without that end user engagement, you're just making your project more expensive. Right? Like, that's where you get your. So that's what I'm kind of struggling with, is like, how do I get my end users up to speed so that the value, the investment that we're creating in this product is actually used? I don't know if it's going to be used, and if it's not, I'm just making my product more expensive.
And I'll give you another example too. So this is a really good example. So just something as simple as this. Okay, because I think smaller firms, it doesn't quite play out this way, but for us, okay. So you've got a designer approach. He needs survey data. He doesn't even know the survey data in that area. So he reaches out to maybe product surveyor, or most likely a senior. So then a senior reaches out to the survey senior. And that survey senior reaches out to a project surveyor. That project surveyor says, well, I wasn't working on any of those projects. Oh, that must have been Ralph. Ralph retired a year ago. Okay, well, did he work on it? Like, what did he have? We don't know. They take some time, a couple hours, just looking for that data. We got something. Okay, so he tells a senior tells a senior, yeah, they got something. Okay, well, I think we need it. Okay, right? So you got this going. And so one of the first products we're going to build once we get the data centralized down in San Diego, if we had to pick a district to start, San Diego's the one, right? And is going to be a series of web maps and story maps. And so what that'll do is at a bare minimum, it's going to give them a new research tool, at a bare minimum, right? So then as we're populating the system, that's low hanging fruit. That kind of stuff's low hanging fruit because now guess what? Now when corrosion needs data, it goes to that web map just for design, which will have its own unique buttons and experience. He can figure out what he needs if he wants that, depending on the district. This is the other thing too, like we're realizing, and this is a hard thing to do. One size doesn't fit everyone, everywhere, every time. That worked in 1940 when everyone was using a steel tape and a transit, but it doesn't, like with the complication of the technologies work. So we got to figure out how to basically support more people in more ways, right? And so but in District 4, I know the relationship there with the designers, they would probably be happy just to be able to get them the data right off the website, right? So now Ferocious and even that whole line of communication just got cut out. And now Ferocious more like going to 7-Eleven and saying, okay, it turns out there's data. This is what it was used for. This is what it was at. I can use that. It's got a good shelf life. And then he's off to work. So we'll also be doing stuff like that. So I think the foundational stuff that Chris touched on is 100% true. But then we're also going to be developing these products, low-hanging fruit sort of products that we just don't have it.
Even more to it, there's another good example is right. So, me as the construction guy, right? I'm responsible to go build, I don't know, call it a new 4-mile line. We did a whole bunch of right-of-way acquisition in there. It happened 7 years ago. Where are all those agreements, right? So there's agreements that were made. Oh, so-and-so has agreed to sell you this property for this dollar amount, and I want this special fence put in. Well, 3 different designers occurred who worked on this project later, and oops, somebody forgot to make sure that fence was there, right? Now, I'm out there building it and somebody's screaming at me going, you guys agreed to put me this fence, and now we're like at the position of, okay, where is this right away? So we can centralize that data to a place where now I, as a construction person, can go find that right of way data that's queried in that area. Now all of a sudden I have better information and I can do a better job informing, the public, or in this case, a specific property owner, where we're putting their new fence. So, just anecdotal evidence, but I've been that guy that's getting screamed at because I didn't have data that I said was silence.
My favorite when we actually build a fence and not on our property.
Yeah.
On that note, maybe a quick final thought from John, and then we'll take a really short break. Go ahead, John. Think about value. Yeah.
Okay, so basically it's ecosystem slide where you had different images, vendors. So my question is really, are you developing kind of a Symphony-based under the hood linkage, all these different sources of data only, or are those platforms interoperable with each other within the ecosystem?
So a small select group of platforms will be interoperable within themselves.
And all the ones in the circle are interoperable with these. Is that something they're doing sort of on a customized just you guys, or is that
So that's the best part about it is these things are going to be baked into their commercial releases when they come out.
So going to be these features.
Yeah. Well, some of them are actually out right now. You may not know that they exist, but the new release of Civil 3 2024 actually has a piece of this in it, right?
All right. On that thought, let's give our Caltrans friends, value-adding partners a good round of applause. All right. So can we all please just take a brief break? And then local time, let's start at 3 p.m. sharp. Let's start 3 p.m. sharp. We'll go from 3 p.m. to 4:15 p.m. And then afterwards, we can have some beverage out in the terrace and we can catch up more. So we have still quite a few lineup, as you can see. So join us at 3 p.m. sharp. Thank you. Thank you. Going to go around the nation a little bit to hear from some remote participation, remote speakers joining us from Michael Baker and joining us from Esri. Following that, we have two additional SciFi PhD students to tell us more about BIM-GPT and also video computer vision. So let's go ahead. And then, of course, we want to make sure that we have some good time for us to chat locally. So yes, thank you so much for joining us. Let's turn the floor to Michael Baker.
Hey, thank you. Can you hear me okay?
Yes, Joe, we can see you, hear you well. The floor is yours.
All right, great. Well, thank you again for this opportunity. Again, I'm sorry I couldn't be there in person with you today, but I'm going to give a brief presentation on some of the experience with using open standards, particularly IFC exports in bridge projects, and even further focusing on projects with contractual models or model as a legal document, in which our model files are actually the format that will be used to construct the bridge and eventually used in asset management activities. So I'm Joe Brenner. My background is a bridge engineer. I'm definitely not a developer. I've been working on production bridge projects for about, I had been working on them for about 8 years before starting to work a little more heavily in using model-centric and BIM approach and really getting plugged into more the national research on the topic with FHWA and other leading organizations on the topic here. So in my current role at Michael Baker International, my responsibilities include developing and implementing technology and refining workflows for our clients and internally at Michael Baker. But I'm definitely putting on my bridge engineer hat for this presentation today. So first thing I want to say is that my presentation will definitely not be as technical as some of the others today. I know that, but in the 12 minutes that I was allotted here, I'm going to take a look at IFC, specifically in US model as a legal document bridge projects. And even furthermore, specifically at workhorse type bridges. So not your signature cable stay or arch structures, but the everyday bridges all over our country here. And I think that's an important distinction here, because sometimes some of the major projects, they're kind of an ecosystem all on their own, and they aren't really indicative of what's going on with most bridge and civil infrastructure owners and what they deal with on a day in and day out basis. So with that in mind, I'm going to try to answer these 3 questions here. So where are we with IFC for use in these typical structures, right? I'm going to go through several examples. For these examples, we're using obviously commercial software here to develop these models. Sometimes by the time we get to construction, we're several versions behind. So we're still in these cases, we're still using IFC 2.3 in these examples. We're sometimes limited by our clients in terms of what software we can and can't use here. But we'll show you even at that stage how they've been extremely helpful even in those current states in these particular projects. Next question we're going to look at is, where do we want to be in the near future with some of these BIM for bridges and other of the work that's going on internationally right now? Where do we want to be here shortly? And then finally, ask, why is this even important? Why do we need open standards? And I'll leave you with an image that I hope is as scary to you as it is to me here. But we'll get to that here in a few slides. So first, I want to go through several past and current examples where we have used IFC in these particular projects. So the first example I have is reinforcement, and specifically reinforcement fabrication and placement. So these are some images here from one of the first model as a legal document bridge projects in the entire country. This is going back several years ago now. 3-4 maybe years ago now, before when that started. But when we delivered the project, the fabricator couldn't use the native files. The rebar fabricator couldn't use the native files other than just to view, but really couldn't do much with it. So he asked for other formats, asked for the format that of course that works directly with their with the software they used. We couldn't do that, but we could provide an IFC export, and they were actually able to use that and import that directly into their software and get pretty much all the information they needed. And again, this is going back 3-4 years ago, when this is first getting going. And I think it's a testament to reinforcement as a great place to start in this area, just because of the commonality between both the vertical and civil structures, obviously. But the reinforcement fabricator was able to develop what they need in order for their fabrication process, but also develop placement drawings like the ones you see on the left side of the screen here, so that their iron workers could go out and place and tie these bars, right? And even I think it's important to note here that there are going to be whole groups of people in our industry here that are going to be a little bit further out in this, and they need to also be considered in the development, like these iron workers. And even just pulling in and being able to use a 3D isometric image, if you will, even if they're using paper, I think is a good way to start. Maybe everybody's going to have tie bots out there, and there's going to be placing the rebar and tying it here. But I think, at least again in the near future, it's important to make considerations for these groups of people that are only used to being out there with paper plan sets, specifically and modeling the legal document projects. So the next example I have here is from actually an external design review that was brought to us by a client. And this is, again, a model as a legal document project. And specifically here, we're looking at the bearing pads in a bridge abutment model. So you can see here on the left image, and these next couple slides will be going back and forth between native import on the left and then IFC import on the right, kind of comparing the images here. But the arrow you see on the left is actually showing obviously some wrong geometry produced in the native model import when we brought it into this review software. And looks like it mixed up some of the export of some of the layers there of the bearing pad. And then in other cases here, this other arrow, see that it just didn't import the geometry at all. So something happened, it just did not come in at all. And one thing to kind of stress here is let's say a practitioner here for projects out in the field, we don't have time to wait for software, updates and implementation. We have to deliver now. So we were in, how do we do this workaround mode here? So we thought, hey, let's try an IFC import and see what happens into that same software. And the image on the right, you see the geometry came through perfectly here and complete. We were able to kind of bring those all together into one place. Next here is the same model, now looking at reinforcement again. But the native model here on the left shows some cases with the reinforcement in arrows here actually being placed outside of the footing in this particular case. So obviously an issue there. We also see when you kind of compare the two images here, you can see that we're missing some of these bars up in the parapet or the barrier section of this wing wall. And then probably a little bit harder to see here, but this is actually, we found that the reinforcement when the import came in, the model, the diameter was off in the native import. But when we looked at it again with the IFC export, we were able to verify and bring this information in completely and geometrically correct for this design review. Next example we have is really the really scary one for me here, because it comes from the field in construction. So this image on the left is actually a picture the surveyor took of his laptop screen, directly from his phone. So he was out there, on his laptop screen in the field, took it from his phone and sent it to me in a text message showing how the footing that we designed and modeled look like in the software here. And he was going out to stake that the next day. And this is what it looked like. And obviously, this was a combined footing. It was showing up as two separate footings. Obviously geometrically incorrect. You could see some of the piles here as we're showing here, some battered piles, and you can kind of see the H piles there coming in. Obviously some are even outside of this footing. So obviously, way off here with the native import. And luckily this was wrong enough to throw flags up here and prompt the surveyor to contact us and say, hey, what's going on here? So we looked at it together and said, well, let's, looked at, what he was able to import in the computer or into his software, I should say. And we said, well, let's try IFC export. We've had success in this in the past, let's use that. So, and on the screenshot here to the right, you can see that this is actually the same software with an IFC export on that same footing. So you see the combined footing and the bars here, and we're able to verify that coordinately correct geometry between our two softwares here, with that same component. So those are just a few examples of where we are now. But where do we want to get to here in the near future? So obviously successful, able to do a lot with, especially in the field, get information quickly out there, interoperability to different stakeholders quickly, right? But where do we want to be now in the near future? So I'm not going to spend a whole lot of time on this here because I think we're all aware of the work that's being done, again, nationally and internationally here, and what's available now and hopefully implemented, regularly in software soon with the Bridge Pooled Fund work and IFC 4.3 and beyond. But I do want to mention the importance of having these elements and property sets for our civil structure elements and just civil elements in general here. Like we can with some of the reinforcement specific elements, you can see some of the export here from our reinforcement where we have our property sets and everything here. But also now looking at, for our other elements, being able to have that and go there. I think this is really what's holding us back in a lot of cases, to be able to consistently use this in more applications. Right now we're struggling because we can't set up the attributes that we need for these model as a legal document projects, because they're not just information that's nice to have, they're part of the contractual model here. So right now, because of geometry and attributes not matching, in some cases it forces us to essentially keep two versions of these models, at least for some elements, which everyone knows here is horrible practice, right? And a recipe for trouble, but is necessary for where we are in some cases. We're obviously watching that very carefully, but able to kind of keep these projects moving along and make sure we're noting what's some lessons learned and where we are here. Another important aspect, I think, is where we want to be is the ability to store and transfer what some software called save views. So have the ability to, we have the ability to kind of hold things like layer and level content that comes through with some of the exports, IFC exports here. But what we found is, especially when individuals are getting into this the first time, into these model viewers and 3D models in general, it's helpful to have a set of views for the model for them just kind of ready to go, at least as a starting point there, not to just kind of be looking at a model and trying to break it down and understand, things like the layer or level symbology that, every DOT has a different one and they're not always very clear in exactly what they're showing. So if this can be, having these save views can be similar to having, the traditional views in a 2D plan sets, or even, just 2D sets in drawings, plan, elevation, sections, those types of things. But now with being the ability to have save views in the model, we have a more dynamic view in these viewing softwares. We can we can use that as a starting point and look at different elements there, but we have, again, starting points where we can go in and look at specific things. And if we're able to transfer these view attributes from software to software, for example, as part of an IFC export, to me, I think that would be extremely helpful especially again in this transition period. I'm not aware of any of the functionality today in terms of storing and transferring these views, but maybe others have some there. It's just something that we found from our practical experience delivering and trying to build these projects that I think is important. So just wrapping up here finally for our last slide, why is this important? Why is this important specifically to me is in our experience going through this? And I'm just going to leave you with this image here. And I think this is really the best thing I could leave this. And this image haunts me, to be honest. It literally keeps me up at night. I've spent nights thinking about this, the fact that my model that has my seal on it, my PE seal on it, that can be viewed from one reputable software like this and another through, a set import, or even through just straight opened as an allowable file format. That scares me, right? And it keeps me up at night. It stresses the importance to me of continuing to drive this home and develop it, how we can have one open standard model that we can maintain and use, that all software has full access to implement, that all the stakeholders can be able to get in and use what they need to for these, obviously with different exports, but one model to maintain that can be used in these applications. To me, that is what keeps me up at night and why this is so important. So again, I thank you for the opportunity here to present, and I'll turn it back over to those of you in person there.
All right, let's give Joe a round of applause, or virtual one. Yeah, and then why don't we hold all the Q&A towards the end, or feel free to send it by text. Next, we're going to hand it over to Marc. Marc from Esri.
Very good. Are you able to see my screen?
We can see you, we can hear you, and see your screen. Thank you, Marc. Please take it away.
I will. Thanks again for the opportunity here. Like everyone else has said, this is a great collection of folks and perspectives. I'm glad and eager to share mine. This idea of seeing is believing is very timely. It's one that Esri in particular is ready to deliver on. We'll see here in the next few slides. I'm going to go through pretty fast-paced, pretty high level, but we'll jump into some actual demos. Similar to what we just kind of saw, where we came from and how far we've come is going to be a sort of a theme of the content I'm going to be sharing here. I always like to start off my presentations with sort of a recollection of where we did come from. This is Ivan Sutherland in the 1960s, what many people believe to be the first CAD application called Sketchpad. Ivan was an absolute just giant in the world of computer science and user interface and GUIs. And you can see him here with a stylus and a multi-key keypad, drawing on screen, touch screen, drawing out the multiple views of a chair. Fast forward about 20 years, and several of us I know on the call in the room there were struggling to use the latest technology to create 3D views out of 2D CAD. Flash forward about another 20 years, and we were at least able to do multiple scales in various applications. I come from the world of Autodesk and AutoCAD. So that's what my screenshots happen to be, but we might have been using other applications, but the evolution was similar. Just about 20 years ago, this was kind of state of the art. Another 10 years forward, and we finally got into the world of BIM fully, started to get to a point of critical mass, at least in architecture, really doing 3D design, object-based design, geometry, graphics, properties, all coming together. And here we are 10 years later, and the ideas of GIS and BIM and open BIM, multiple formats of BIM authoring environments coming together in context, in 3D maps. In this case, the little blue columns you see on the bridge represent IoT sensors, delivering back into a dashboard-like view the environmental conditions, the temperature, the seismic activity of construction that's taking place next to this very old bridge. This is a model put together by HMTB, 110, 115-year-old engineering consulting company. So as far as kind of where we came from, where we're going, and where we're going to be in a few years, just looking at a few images here makes you think about how fast we've evolved, and who knows where we're going to be in 5 or 10 years from now. And it makes me think about this chart, which I've always promised to not show and talk about how unproductive the AEC industry is, because I don't think it's accurate. I think it's in the old disgrace of AEC that we aren't productive compared to the other industries. I think it's based on false impressions that our industry is stuck in its old ways. I just don't think that is the case anymore. And I'm going to show a few examples, a few more that highlight that. I was just looking for some research to quantify and prove that we aren't back in the old days like we've been talking about in tech shaming ourselves. Those who have been using tech, this is a survey from OpenSpace last year. Those who have been using tech over the last decade or so are increasing their adoption, increasing the use, increasing the number of projects where they are using technology. Those who had been skeptics and pundits against using technology to make themselves more productive, they're actually adopting at a higher rate. And it's coming from a call from above. Management within the AEC industry is encouraging the use of tech, persuading team members to use better methods, removing the analog processes and replacing them with digitization. And you might want to stop and think, why are these things happening? Why are things changing? And just a word cloud of reasons, from digital twin becoming a real thing within the AEC industry, sustainability within our industry becoming so important, energy efficiency becoming front of mind. But I would argue that location, GIS, the idea of context is suddenly become critical in our design processes. We've come to realize how important location is. Everything gets planned, designed, built, eventually operated in context. And although that's always been the case, our technologies and our recognition of the importance of context hasn't necessarily been the first thing we thought of. Location acts as a unifier. It integrates, it connects the many types of AEC data, the schemas, the formats that come together and need to be used to solve problems in our industry. And just looking across many industries, I think you probably agree that the AEC industry works with more data types, more file types, more complex data than most other industry. And in many cases, location acts as this unifier, a common denominator. And it's enabling a digital transformation that clearly is happening in our industry. Numerous times I've been in front of large audiences and asked the attendees, who here is not in the midst of a true digital transformation, not just digitizing their processes, but changing the way they work. And everyone agrees that's where we're at right now, in the midst of a significant digital transformation. So like I said a minute ago, I think gone are the days of tech shaming our industry for taking a low-tech approach. What we've seen today, a couple examples I'm going to see here, and what I see around the globe is that tech adoption, tech usage for productivity and safety and sustainability is just become the norm. So what are we doing at Esri to support this? I joined Esri about 3.5 years ago after some almost 30 years now in the AEC space. And Ian might not recall this, but he was one of the first people I reached out to and said, Esri needs to be a member of Building Smart. We need to take an active role. If we want to be taken seriously in the AEC space, Building Smart, we need to invest and be quite visible in that space. We work with the ODA libraries. That's how we are incorporating IFC into our applications. We're very active in the Open Geospatial Consortium. We put our libraries up on GitHub. We are supporting open standards like CityGML and 3D tiles, and a founding member of Overture Maps, which is a sort of a global approach to making sure that map data is interoperable. We've got 2 applications that I'm just going to take a real quick bit on to just highlight. And I know most folks in AEC are very familiar with the CAD and BIM and scheduling applications, but GIS is a little bit of a misunderstood area of the industry. I'd argue that anyone who's using a CAD or a BIM tool should have a GIS application in their same toolbox, ready to pull out, to bring that content in, to spatially analyze it, to understand it in ways that you just can't do in a documentation or a clash detection like tool. And this is our flagship product called ArcGIS Pro, where you bring together the many kinds of layers, visual layers, non-graphic layers that get represented in spatial coordinates. And then another is a fairly new application called ArcGIS GeoBIM. We started out combining Esri's online map repository called ArcGIS Online, initially with Autodesk Construction Cloud and BIM 360 as a way of bringing together that information that is typically spatially oriented, maps, 2D and 3D, with the information that might be stored in repositories that isn't necessarily spatially organized, but is critical to understand projects in context and keep all your information organized. So just a couple of products that consume IFC files, render them, visualize them, and make them available for spatial analytics. So sort of now where we are and kind of where we're going. The next few slides and little videos are content that I put together for the the Building Smart Summit in Rome back about a month ago, just a few days before that conference, realized I needed to show some real live IFC 4.3 data in Esri's applications. So reached out to Autodesk, asked for an IFC file that came from a Civil 3D model. So exported as 4.3 here in the city just up the 101 from you guys. So this was a IFC exported file brought into an ArcGIS Pro environment and then saved out to a web scene. And you can see, full fidelity, all the objects, slicing and changing your views. I turned off the base map, zooming in, and you can see all of the objects that made up that model in Civil 3D and that bridge available here in a web scene. Again, wanted to make sure that we weren't just showing one particular vendor's support and their IFC export, that we were able to consume from various formats. Did the same kind of thing with Bentley. Reached out to my friend Bob Minkowski at Bentley and said, hey, can you give us an IFC file? Again, something infrastructure to show in context, in a map-like view that we could show our ability to consume IFC data, the geometry, as well as all the properties. And he shot me off a file. It probably wasn't him, it was one of his product managers. And we just brought it into ArcGIS Pro, saved it out as a web scene, and you can see the geometry obviously is there, and then all the properties that would have been in the authoring tool come across ready to be used for spatial analytics. And then actually in Rome, there was a couple of vendors there who I wanted to do the same thing. Realized that a couple of BIM authoring tools were nice to show, but there was much more than just two companies who are producing 4.3 files. So this company CSPFEA, probably the longest acronym for a company name that I know, we're on the floor and challenged ourselves to, between their Italian and my only speaking English, received a file. Shot it off to one of my program managers back in California while I was there in Rome, and brought it into a web scene, decided that it should be snowing on the bridge. And again, same concept, that all of the geometric objects come across with full fidelity. And as you'd expect, you click on any of the individual parts and pieces, and all the properties are available for exploration, and certainly more than just visualizing the properties, but all of the wonderful capabilities that GIS delivers for spatial analytics and temporal analytics as well. And then finally, our friends at ACCA Software actually connected me with another vendor, iStram, who develop infrastructure models, again, a 4.3 file, brought into context in a map, all of the objects. This is a combination of road and rail, signage, striping, again, the objects themselves visualizing in full fidelity, as well as all the properties that you would expect to see ready for GIS analysis. So those last 3 or 4 examples were very much, I would say, sort of science fair projects. It was, give me some data, we'll throw it into a scene just for demo purposes. I've been working with Skanska pretty much since I started at Esri as well, and I've always held them in high regard as a very innovative company, and have shown this demo a number of times. This is a real world project. This is, I believe, either HS2 or Crossrail in the UK, where the IFC data is their lingua franca. It is their collaboration language. They're bringing it into a GIS environment. They're developing survey tools that allow the construction team and the design team to go out in the field, collect existing conditions in context, location based. And for every one of these little red dots you see on the map, that is a situation where a safety condition, an existing condition of the job site, required additional exploration and understanding. So a combination of location-based survey tools, IFC data in this dashboard-like view allows the construction and design teams to manage their processes, reduce costs, reduce risk, and just deliver projects better. So with that, just kind of a high-level view, at Esri, we've been working on our BIM integration going on a decade. It started out with ArcGIS Pro, an application that is 2D and 3D, adding more capabilities, bringing in Revit integration, adding IFC support over the last few years. And just kind of anecdotally, we joined, like I said, Building Smart 3 or so years ago as multinational members, and kind of struggled to get 5 of our distributors excited and on board to be part of the movement. Just came back from Rome, just sat down actually with Clive and Aiden in Rotterdam, and let them know that we've got 20 of our distributors plus our headquarters office that all want to be members and active and participants. So I think our our participation, our investment, our involvement, where we're going with IFC and openBIM in GIS views is just going to accelerate, hockey stick curve. So with that, a few ways to reach out to me, to find me, hit the QR code, drop me an email, find me on LinkedIn. Thanks for the time.
Thank you. Thank you, Mark.
My pleasure.
Just for Joe and Mark's information, I think the room was paying 120% attention, even with some good kind of like nodding, just for your information. Thank you so much. We'll hold any Q&A towards the end. We have 2 more exciting presentations to come. So, so feel free to add on to your chat or organize your thoughts. So next we'll transition to local, and let me share screen also. And so this morning we have heard from Steinar, who sorry, cannot we is it the second one?
Second one.
There you go.
Yeah.
So this morning we heard from Steinar, one of our PhD students here at Stanford, about kind of like his Norwegian experiences, connecting that with client objectives. And then up next, we have 2 other peers of Steinar, starting with Junwen, and then later on with Jinpu, to actually tell us about some of the ongoing research about BIM-GPT and also video-based detection. So the floor is yours. Thank you, Junwen.
Thank you, Kevin.
Hold on, let me also do this very quickly. So, and then here, try it again. How many to? Oops, sorry. Yeah, we can hit this one first.
Okay. While it's setting up, I'm Junwen. I'm a 4th-year PhD student, supervised by Professor Martin Fisher and at the SciFi, and also Professor Monica Lambs at the CS department, and also the Open Virtuals System Lab at Stanford. So today I'm showing more on the research side, less practical, but to see what or the edge of the GPT or this type of technology can bring us by integrated with the BIM. So I might start from the motivation of the problems that it currently is challenging to efficiently retrieve BIMs, retrieve information from BIMs. Even as the BIMs adoption goes a lot, and a lot of multidisciplinary information are integrated inside, BIM becomes bigger. A lot of the interface become complex. So it might be people that just like professionals not have that expertise in the BIM, not understanding all the BIM structures, all the data structures, they might have a kind of a difficult hands problem. And on top of those, if you need someone help you to retrieve the information, like there's a use case from a construction and superintendents, they really want to figure out outlets, whether they're installed incorrectly in this room, but he has no excuse. So that skill set, so he might need to wait for us, the VDC engineer, to help them to go into the BIM to find that for them. And also, even you are expert in BIM, there are so many buttons, so many tabs you need to fill out to really retrieve the things you need to support your task. So this is kind of summarized as slow hand problem. So just like a 3-year-old child can ask Alexa to play her favorite song from the list, why couldn't virtual assistant help the professional in the AECO industry to efficiently retrieve information? So, but however, the existing approach in construction hardly support the natural language interface. This is the more traditional rule-based NLP methods. They need to understand the grammar of the sentences. They need to figure out what is the keywords or key phrases before they can mapping out to a structural query to retrieve the information. So it takes a lot of engineering efforts to construct all those rules. While the machine learning based methods, like all the Watson's, Alexa, Google Assistant, they are having this type of a natural language, like search for the wall that has a height of 10 feet. Then they extract the intent, that's a wall parameter is high, the value is 10 feet. But they are suffering from
they need thousands or tens of thousands of these mappings to educate a machine learning model to retrieve the information. So then the emerging GPT technology present new opportunities. I think everyone have heard or already play around with this ChatGPTs. It has kind of state-of-the-art performance without any further training, but with just a prompt as a in-context learning. You can excellence in the text summarization, text classification, information extraction, summarization, and question answering for you. So what's the missing here? GPT model has trained on trillions of text data, but they don't understand what is the construction context, what is the BIM information retrieval concept. So the prompt is the way that aligning the models with what we need in our use case. So that's with this motivation, we come up with this BIM-GPT prompt-based virtual assistant framework. Basically, the user will use natural language to query and get the results in natural language and also have some visualization through this web-based user interface with chatbots and cloud-based BIM. And the key here to interpret a user utterance or query is the natural language processing module. In particular, the dynamic templates and the prompt manager, which we will dive into details later. So this NLP is connecting with a database or cloud database that have all the BIM's information and also connect with the external GPT server to like OpenAI's APIs. So in order to develop a versatile virtual assistant, there are five important critical tasks they need to achieve. First, understanding the user utterance, that is NLU. And then the NLG is more summarizing what we get from the database and then provide the answer. Question answering is more generic QA questions, not specific to this database, but more general. But understanding the user utterance is so difficult, we cannot do it at one shot. That's why we decompose it into 3 different subtasks. Understanding what is the intent, that is what is the type of the object people are querying it, what are the parameters you involve, and what are the querying values. And we don't want to create all the complicated rules and we want to make it lightweight. So that's how we come up with this dynamic templates for the prompts with these 5 components by dynamic changing what according to the user utterance, and then you can accurately interpret it. So give you an example. This is intent prompts examples. So there are 5 different components. The system, which is providing the role to telling GPT model you are a virtual assistant helping to get information from BIM. And then the second one is relevance database information. So we are active dynamically pulling information from the BIM database to help to provide some context to teach the models. And then the third one is more task oriented. So this prompts the purpose is to understand the intent. So you explicitly spell out what are the tasks you need to figure out. And first task is find whether it is a BIM query or it's a general question. Second task is just retrieve a category or a type from those. And then tell them the formats. The fourth part is few short examples, which because this is provides all the above is more instruction or related content. This is more providing what would be the inputs output looks like. Direct provide this example really effectively ground the GPT model onto our content. And the last one is just this is the user utterance that people may ask. For example, who is the manufacturer of 14569? So because we have one template to do all the 3 different tasks, so we developed a prompt manager to monitor all the states and all the state of the current the state of the interpretation and also what information they needed to pull from this database.
So you first classify the user's intent, either it's a general question, then let the GPT handle it. If it is a BIM, then find out what is the parameters. And when you want to look for the parameters, some information about the parameter might be useful, and then just do it. And then to construct the pumps, then next is similar to apply it to understand what's the value. And after you retrieve, you convert the natural language into a short-coded query language. For here, it is a MongoDB query, but it can be any type of query. Then you will want to summarize it, the result. You just provided what you retrieved it in a JSON in some format, but can summarize the natural language answers to the users. So this is a more detailed example of how it really works to interpret who is the manufacturer of pump 14569. But this is too much detail, so I just let it put it here, and then if you're interested, can go back to see it. So the BIM-GPT that to validate is its efficacy with evaluated on a BIM-IR information retrieval dataset. The datasets work like all those natural language queries, and this is those are structured label for the intent, the parameter, and the value. So basically, we should understand what is the type of it, what parameter it involves, and what is the value of it. By using the previous method we construct, then the performance we can achieve 83.5% accuracy without any data incorporated in the futures. Just let them understand what from his previous training with all the context we provide in the past. And then we also try to incorporate 2% of the user utterance lie in the lab, and then provide them the correct answer in the few short examples. With this 2% data incorporated, the accuracy can bump up to 99.5. So an existing methods that utilizing for the same data set, they need to utilize 80% of the data to train a model and then to achieve a similar accuracy, 99 point something. So this is a huge 2% data efficiency gain compared with 80%. So with that, we want to see whether this really works from the real BIM models. Then we implement a virtual assistant prototype for a hospital building. So this is the lab is the user interface when you can type in the questions in natural language, and on the right it is just integrated with Autodesk Forge, or they might have a new name, but this is all the properties within the, and then they are matching it. So this is kind of first. This shows how the user interface to retrieve the information with the prototype. So first you might just input search for the building objects on the 6th floor. Then you can get it and also have some summaries of the objects on the 6th floor. And the next one you will get, can you show me all the pumps? Then it will select them because you search them by filtering their parameters, and then they have the ID retrieved, so it can visualize it. And then you might want to ask, do you know where I can find the specification of pump 1465? And then you highlight the pump and then provide you the PDF link in the document. Is just a new way to interact with it and retrieve all the information from by filtering using natural language and get it. And also, because of the generic question answering capability of GPTs right now, you can ask him some general question. Yeah, explain me how the hydraulic supply system works, or explain how what are the frequent failure of those air supply systems. That it might can provide you some useful information. So at the end, this is a summary. So our GPT framework can facilitate the development of virtual assistant for building information retrieval by substantially reducing the engineering efforts and the data requirement. And we advance the understanding to how to design the pumps to leverage the GPT models for any natural language-based automation applications. And then in the future, we will conduct user study to assess the impact, how the virtual compare with the existing graphical interface and that kind of works for affecting the efficiency of BIM IR. So maybe also extend the prompt-based approach to automate any other use cases, because it is just converting unstructured natural language into structured query or structured data. This can be applied to any other things or any Excel sheet, Excel templates that it can provide you a structured information. So thank you.
So thank you. Thank you, Junwen, for sharing with us BIM-GPT. Again, with 2%, pretty good value statement, right? 2% of investment can boost up our accuracy up to 98%, right? Just based on a research project. Just imagine if we all can team up with the open standard community working on that and let AI catch up more to serve the construction industry. What more can we do for all the assets we see, right? So thank you, Junwen. And then next up, our final presentation of the day, to make it third as a charm, it's our third student, PhD student from Stanford, Jinpu, who will tell us more about your new research idea, and also in collaboration with professionals, in this case, WSP. So welcome, Jinpu. You can use this, can use Klooster. Thank you. Okay.
Oh, hi everyone, I'm Jinpu Cao, the first year PhD student in civil and environmental engineering. And I'm glad to be here to share our recent research, video-based patch level pavement distress detection system, and thanks for the guidance from Professor Martin Fisher and Pooja from WSP, my collaborators. Okay, I'm going to start from the background problem. So currently, in the United States, about 32% of the main roads are in poor or mediocre condition, and we need timely maintenance, so which can help us save up to 80% cost. The first thing is we need accurate, consistent inspection. However, this task, detecting the pavement distress or anomaly, is still labor-intensive. For example, according to a study from Germany 5 years ago, it will take about more than 1,300 labor hours to inspect the about 140 miles road, which is equal to the road network miles in Mountainville. So it's labor intensive. So we want to automate this process. That's why we start this project. See, for example, we can see one of our prototype demo. This video, hopefully it can be played. Yeah. Yeah, so in our final product, when we drive through the road and with our camera on, we can take the video of the pavement surface, fit the video into our model, and we will get whether there is a crack or not. And finally, we will generate a report, which includes the crack distribution and some details or statistics information about this pavement. So it looks cool, right? We also measure whether it's really from well than the traditional method. Yes, it's turn out. Yeah. We evaluate our video-based detection to the traditional manual one, and also the image-based detection to find yes, it is more cost efficient and scalable. These numbers are collected or estimated according to our interview with bridge inspector from WSP. And as a summary, find the video detection method will save about more than 70% compared to the manual method, just in terms of the labor hours we need. And also the performance of this detection method can also get a good performance. Here we use F1 score, which is always used in this kind of task. We will talk more later. So let's go deep into the system itself and how it works. Basically, it's not complex. Just you need to install a camera, for example, a GoPro at the rear of your car, drive it, and collect the videos. Then we process the video automatically and fit into a machine learning model. There we train it and evaluate, test it, and use it in practice. So in this whole pipeline, we mainly have two challenges. One is how to set up this camera, and then how to train or how to detect the cracks. So basically, for the first challenge, how to set up a camera. So an ideal setup should include the following points. Like first, it requires a very common device. For example, you just your smartphone or sports camera, and then it should have very straightforward procedure. Just install it, for example, and also hopefully it can catch as much as useful information and less distraction information like some other cars, which is not what we want. And when we do a lot of research, we find that there are several different setups online, and we make a trade-off between these 3 points: accessibility, efficiency, and also the quality we get. We find finally we use this setup just to install a GoPro camera at the rear of a moving car. And here are some parameters we use, but you don't need to be exactly the same as this parameter. Just do some simple measurements before you collecting the data. You can get which will be used in later of the program. And so next is detect some details about detect cracks from the video. So here are some detailed steps. For example, collect the video, process the video, and finally fit into a deep learning or machine learning model. So here we show some basic information about one of our video demo. It's only like 10 minutes load, like 3 miles, and we collect the frames. We process this video into images. For example, split into frames, resample, label it manually. When we train a model, we need to label some pictures manually. But when we have already labeled lots of pictures, we can just use it. Then crop the frames, so I cut it into small pieces. That's why we call it a patch level. Like we cut one pictures into several different patches. Okay, finally, with all these patches in our patch, you can just fit into pre-trained machine learning model. You don't need to develop by yourself. There are a lot of advanced model developed by salespeople. So we can get to the ACCA score we mentioned before. It's about 90%, which is an acceptable performance. So basically, this is the very basic model for this task. Just a binary classification, just a crack or not a crack. And as a further step, we also extended to multi-class task. For example, we add 2 different classes: the anomaly or the repaired class. We use some plane to simulate a repaired class and see whether we can detect it. And the result tells us, it still works well. It's about 90% performance. And also the work we are doing now, it's about the change detection, which is more intuitive and helpful for industry. For example, just tell me whether this crack is repaired or not. So just from this example, we can see though there's still a patch level change detection, but it can tell you the red one is there is a crack, and the blue one, the crack is repaired. Do a comparison. So another thing I'd like to mention is here we encountered a challenge that in a video we need to match the related frames before we compare before we do the change detection. So ideally, we want to get one frame from the original video and get another frame from the new video, and then compare them or detect the change. But however, because of the GPS is not that accurate, so we cannot get it automatically currently. So we need to manually pick it, or we are trying to use some external accurate device or more computer vision based technology to deal with this problem. This is the work we are currently working on. And also, we also do some preliminary work on from patch level to the pixel level, which is more accurate. As you can see, the patch level, you need to cut it into small pieces, still some eddy, but if you can play with the pixel level, it can be used for more related application. Yeah, so that's like the kind of next step of our research. So yeah, that's all. Thank you. The questions.
Thank you, Jinpu. Well, thank you all for kind of like allowing us to have a condensed medley from Michael Baker to Esri, and then our two Stanford students. So maybe first of all, there are maybe those joining us remotely. Any questions, comments? So maybe Tony, Min, do you see any questions from the border group or any observations from the Zoom channel?
Yeah, we do have a question probably directed at Joe, which is from what do you attribute the distortions in the native format translations? What might have caused those?
Actually, Joe needed to drop off. So.
Oh, sorry. So Joe, it's probably getting late for Joe, so he has dropped off. So, I think, sure, yeah.
Okay, so some of the things that are most exciting from these three final presentations have been quite contrary to misapprehensions in the industry. We're finding that IFC is actually quite reliable. And Marc gave us really good metrics on this. We also see that there are exciting new ways to generate the models and to use artificial intelligence to look at visual records in order to be able to perform things like extensions. These are quite inspiring, and hopefully, Calvin, you can see the faces in the room. They've inspired thoughts about what we might do in seeing is believing. So with that, maybe we can open up the conversation and see where people are the most energized and how we can harness that over the next 300 days or so to do some really exciting projects.
Sounds good. Thank you, Tony. So once again, welcome any remote participants to raise your hand, type in your questions, or share your thoughts. Maybe coming back to Stanford, reactions, questions. Again, we want to frame it to be what we all can do together by the end of the year. Please.
Okay. On your camera proposition, would it be assistant to you to have data sets that were centimeter grade precision with roughly those same parameters, i.e. from like a mobile mapping system?
Maybe you can come up here so that they can see you. Yes.
Oh,
yeah. Yes.
So can you say the question again about centimeter?
So would it be beneficial for you to have, let's say, a better camera and a better positioning system for that camera? So you would have centimeter level GNSS based positioning for that?
Yeah.
And /or LiDAR data sets that were also geo-coordinated, with correct parallax between an oriented point cloud and exactly photo data.
Yeah, I think better device always can increase the performance, but we would like to make a trade-off at use for example, in terms of the resolution of the camera. It seems in just use our smartphone or a sports camera, its resolution is satisfying currently, but so which means we might not need the more expensive camera for this task. And in terms of the GPS or more accurate location device, currently it seems we might need better device which can give us at least more when we matching the two frames from different videos. It can help us solve this problem. Yeah.
What do you think the cost difference between a GoPro versus your centimeter level?
$1 million. But we happen to own 5 of them right now. So
Is Caltrans already collected this information?
No, that's exactly right. That was exactly my point. It's already collecting this information in 5 mathematics. So if that's of interest, we can probably provide you some of that data.
So I think that was Jinpu presented that to the SAFI board. Remember, Renata talked about presenting her idea to the SAFI board 30 years ago. He did that maybe 30 days ago, and there were some questions from the broader industry. Is that exactly, could that ride upon some of the existing imaging and collection system from Caltrans and others, and whether it can be served multiple purpose?
So it sounds like part of the heart of your project though is to try to do it as cost effective, right? That's kind of, did I do you right? Like you're saying you're trying to pick a device that was accessible. That's kind of what I got from the presentation. You wanted like a GoPro, right? $100, $200 camera. You're trying to bring a solution with cost effective.
Yeah.
Was that part of the whole of your project? Or no?
I think it's part of our project because there are already some research. They use some 3D lidar detection technology. They can get a better performance for at least for the distress detection task. So we're trying to just use like more like GoPro or just a smartphone to finish this task. Yeah, it's one our project.
Yeah, that's more of a challenge, right? Because now you're not taking $1 million data set. Yeah, right. It started with $1 million data sets different than starting with a few images and then having to train models to be able to work with that low megapixel resolution.
Can I ask if having the LiDAR would enable the greater risk detection so that you see something that is more likely to be dissolved away in rain or earthquake and that type of thing?
Well, it could also be, it's it's a different dimension, right? So LiDAR, you're going to get, depth potentially. So there's some additional measurements that can be attained or, can be obtained from LiDAR. You can also get intensity values. So you may be able to detect different types of cracks with,
And then with more and more EV, we have lots of imaging system also aging. What can this build up in the future in terms of team source and cloud source and reporting? Question six.
Question, so I'm calling it your research pavement management system. So my question is about your deep learning engine that you have. So do you develop any synthetic catalog of different types of cracks in order to teach your deep learning engine in order to classify the different type of cracks you have, or do you just rely on the images that you pick up?
Yeah, I think the message we need to label is we need to tell the algorithm what is the repaired cracks, and like these pictures they are repaired cracks. These pictures they are healthy pictures. They are like anomalies. Something. When we label it and feed it into machine learning model, I think they'll learn it by themselves.
And what is the average time of your machine learning in order to learn the different types of, at least run some tests on it and see what's the average time?
Yes, so for this data set, it's about the original image is about 500 and might take 1 hour to train a model. But as currently the most time-consuming step is labeling. You need to tell add these labels by the most time-consuming steps.
Thank you.
All right. We also have Lynn's question, and then I would also like to see any questions for Marc or for Junwen, please.
It's more an idea for Junwen actually. I thought it was really interesting, the virtual assistant kind of concept. I think you were kind of targeting mostly like design and construction professionals that are sort of, building something on site and then querying the model about, how high is this, or, getting facts basically. I was thinking another audience really is lawyers, is legal people, right? Like, no, because in the ISO 19650, the BIM standard, they have 4 sections of that common data environment: work in progress, shared, published, and archived. And that archived section is this treasure trove of, all the past versions of the models. And so the argument always is that's a great, data audit trail, for lawyers to go in and figure out, what happened, where did someone make a boo-boo, So in that space, like, I guess the question to the virtual assistant would be, when did this flash happen? When did, when did we, interfere with that certain clearance? Those kinds of issues and sort of the time dimension in terms of the versions of the model and when this happened. Was the model contractual? Was it not? All that type of stuff. Who submitted it? Did they have a look at it? And all that stuff. It's a whole other level, but it's just kind of an interesting idea because lawyers probably have to deal with the most complexity to mine all of that data that's in this archive.
Yeah, thanks for that question. I think it opens up my mind of how would the lawyers here in this under this context, the change of the BIMs. But my thinking is more aligned with like GPT in general, applying to the legal use cases, like understanding contract and identify risks from the construction contracts, that kind of things. But at the back, I think maybe if there is a specific type of a language, we so-called natural language, because if in the contract that is a term, that is a natural language. But in the additional history of a BIM, that might be, we need to have some type of knowledge had to ground the context for the GPT model to interpret. Without that right now, because I'm not so familiar with those things, then what would be that knowledge we need to map to so that we can create this mapping? Otherwise, especially it will be helpful if both sides are more natural language, or it doesn't really need to be at a super well-defined structure, but need to have some starting points there.
All right, and speaking about engagement with fair use mindset and speaking about lawyers, the next thing is believing. Recently, we were at the Stanford Law School meeting with professor in law, talking about the integration, and Julian was asking from the Stanford Law School, was asking what is a good contract and what can we look with data mining, with machine learning, and indeed also with ChatGPT. So if we are ready for the next Seeing is Believing workshop, we'd love to also engage our legal experts. Maybe any questions for Marc? Any questions for Marc Goldman? He also shared his take, a lot of great examples. I think Ian and I, we really enjoy seeing that, and really kind of like IFC 4.3, it's still going through ISO, but then Marc was able to quickly assemble examples, show us that it's working. So maybe Ian, any reflection on what we have seen from Esri, or any questions for Marc?
Well, we first saw this at Rome at the International Summit. I think there were jaws hitting the table when Marc showed some of the examples, which was in the main auditorium with several hundred people live listening in. And that's why we were keen to invite Marc again to share that today. But the vision of all this open data is interoperability between systems. And I think what we saw is that interoperability starting to play out. So it's not just a vision and a promise. It's actually starting to be very, very real. And congratulations to Esri and Marc. I know you worked very hard. And we had Jack Dangerman, who's the founder and CEO, come on board and literally say, yes, we have to support open data. Yes, we have to look at BIM data. And the best way to do that is implement IFC in the Esri platform. So this is a mandate from Jack after a lot of work with Marc and some of the colleagues at the product level, really starting to embrace this idea. And when you can see that location data and the geospatial models and the BIM infrastructure models and building models combined, it just empowers a whole lot of new decision making by owners in particular. And you can imagine having that resource for asset management downstream is just tremendous. So what we felt was so strong about Marc's demonstration of examples is that it was a very compelling view that the vision was becoming a reality.
Thank you, Ian. How about Marc? What do you think? In the theme of Seeing It's Believing, what we as a community in the US can do more to move the needle more. So any advice for us, Marc?
Yeah, I've been lucky to get over to Europe a few times already this year. Just came back from a conference on GeoBIM in Rotterdam, and then a few weeks before that, an Esri conference where we brought a bunch of our customers to give their examples. And the number of times that IFC was mentioned as the critical piece, the technology language used for collaboration was really amazing. And it reinforces the fact that here in the States, we're a little bit behind in the importance or the recognition of the importance of IFC and openBIM as a means of interoperability. So there's really a wave in Europe, requirements from city, state, country level that interoperability shall be utilized, and that IFC is the format that shall be enabling it. Rail projects, road projects, building projects, airports. I met with Schiphol Airport in Amsterdam, and they are fully on board using IFC as the sort of the language within their data lake for serving plan, design, construction, and long-term operations. So the wave is hitting, perhaps coming from east to west, if you will. So got to be ready.
Indeed, that connects well with what we saw early in the day, what we've heard from Estonia, Netherlands, Finland, Norway, Italy, talk about Singapore. It's really a global trend, right? Ian, and then Pavement, yes.
Also, Mark serves on a committee. We have a cooperation agreement, memorandum of understanding between OGC, which is geospatial data, and Building Smart, which is the building data. Scott Simmons, the Chief Standards Officer, chairs that, along with Jag Miller from WFP on the Building Smart side. Mark serves on that committee. So we're really trying to look at how the two standards organizations can do more to facilitate the kind of interoperability you're seeing, because City GML, IFC, Land XML are all novel formats that need to be compatible in that. And we do have some higher level work going on as a coordination committee. Mark's very involved with that. Thank you, Mark. So there's a lot of work being done at a strategic level, which will then filter down into some of these practical examples.
Thank you, Ian. Yes, Sarah? Yeah.
I was just wondering, in terms of data privacy, there's a lot of times when I'm working on my projects, and it would be so helpful if I had data that the county had or the city had. And I was wondering if the openBIM or GIS is thinking about aggregating that data, or if they're developing standards for releasing more of that information between different agencies for improving interoperability. Thank you.
I think that's exactly a perfect use case, value, expectation that as a community, we can work with one agency, one county, one state, one city, one agency at a time, and see if we can demonstrate that, if we all can demonstrate what is open data, how we can secure data, and actually do something. Because from a technology or from a process perspective, building smart, it's building the foundation to make it work. And of course, with the BIM-GPT and actually AI and computer vision, I think that can just accelerate us or bring our construction industry closer to what we see from everything else. So I think that's perfect. So in the interest of time, we need to close very soon, and we can continue the dialogue. We've got some beverages and some drinks, and we can continue outside of the terrace. So I would need to close, if we may. In that, first of all, thank you. Thank you to Wanata Futa, thank you to Martin Fisher, to Sci-Fi PBL, and of course to Building Smart for co-organizing the events. And a reminder, if any one of you would like to submit for the Building Smart International openBIM Awards, openGIS Awards, we have until the end of the month to go after it. We need more examples from the US, and let's do more. On the other hand, if we may not be ready or not submitting this year, let us know if any one of you would like to join us and serve on the jury along with the international delegation. Building Smart USA has been promoting education. Many of you in this room and your colleagues have taken some of those courses. They include openBIM Foundation, they include project contract management, the people side, and the application side. To get more involved with PBL, Building Smart, Sci-Fi, talk to us, join us. As I briefly mentioned, those of us in person, we can continue to chat outside. Those of you in person who are coming in tomorrow to experience this in person, It will be 9 o'clock to 8 p.m. Feel free to come in at your own pace, or feel free to join the whole day. Again, 31 students from 9 universities who were strangers from January, showing what they could do tomorrow. And then not only learn, let's imagine what can we as a community do to participate, to challenge one another, to learn together. So that will be on the second floor, just 1 floor down, this direction tomorrow. I think that's it. Any final closing words from any colleagues, any participants? Yes, Pavement.
Just I was in Mozambique. That's just wondering, like, kind of expand your work to like cracks on bridges, like on especially on steel bridges. So I know that I work in this area. I know that there is a high demand, and I know it's going to be final scale to find the cracks on steel girders on bridges because it's the main demand that we have in bridge inspection in Caltrans. So using the same method, but in like a more accurate way, and using computer vision that you are using the same for the payment. So just suggestion if you can continue on this direction. It's a high demand in industry, even in West Coast and East Coast.
Yeah, it's a good suggestions. So you mean the region is you have like well, for example, what kind of region? Like the concrete or building?
I specifically talk about steel bridges, and steel bridges there are sometimes they say fracture critical bridges that the cracks is very important. The cracks and finally, so we do it right now. We do it with hands-on inspection on the event.
I see.
But you know, getting the information like using drones or shooting very high quality pictures to get these small cracks. But I know that there are some good research is going on in this area. So
Yeah.
Okay,
Good idea. Thank you.
Well, this seems to be kind of the early stage of his research. So I think all of these ideas, all this industry demands are exactly what SciView represents to be the intersection of industry, researcher, and where education takes place. So I think all these are good discussion, which we can carry outside in a few minutes. But thank you. All right. So thank you. Thank you once again.
Yeah.